Hello everyone, this is Mohammed from PYCAD. In this course, I wanted to give you a quick introduction about how to work with DICOMs, like how to visualize them, how to upload them, how to change the tags, anonymization. And at the end of the course, we'll do a small project which will be building or just reviewing a small application that combines all the operations that we will see during the course. So the first thing that we are going to do is to install the text editor that we are going to use in this course. So for me, I have been using VS Code like since 3 years ago, and I found that it is the best text editor for my projects. But it depends to every one of you. So if any one of you like to use Sublime Text, PyCharm, or anything like that. So it comes to you because it is only a text editor where you can put your text. But for me, I prefer using VS Code. So maybe some of you are interested of using the same text editor that I will use in this course. For this reason, I will show you how you can install it, which is a very easy operation. So I will show you how you can do this installation in your PC. And after that, we go to install the dependencies that we'll use for the project. So the first thing here, I will just go to this link, which is code.vsstudio.com. So this is the website where you will find the versions of the latest version of VS Code. So it depends to your operating system. So if it is Windows, you can directly click on the Windows. If it is Linux, then you can take this, or Mac OS, you can take this. So for me, it is Windows, then I will click here. After that, the download will start automatically. So let me just click here to save. And you see it is being downloaded. Let's just wait for a few seconds. 3, 2, 1, done. Okay, then let's go here. For me, I have it already installed in my PC, but I will just show you which are the steps that you can do. So you just need to click here on the executable file that you downloaded. Then you need to accept the terms and agreement. Then you click here. For me, I recommend you to leave everything by default here. You don't need to change anything here. So just click on next. Then you click on install. For me, I will not click on install because it's already installed in my PC. I don't want to duplicate it here. But once you click on install, it will be installed and you can open it in your system. So as I told you, you can download I will just cancel it here. So you can download for the Windows, for the Linux, or for the Mac OS. If you download the Mac OS version and you have Windows, it won't work. So please take the exact version for your operating system. So that was how to install the VS Code. See you in next videos. And the next thing that we need to install is Miniconda. So for you, everyone depends to the way of coding that you use. So for me, I prefer always using virtual environments. So I don't like to install any Python packages directly in the base environment, which is directly in the system, because this is not recommended. So if anytime you will install something specific for a project that you will not need after that, and this thing will be installed in the system, you may forget it, but it will take the memory and it will cause some problems in your system. But if you install everything in a virtual environment and after that you complete the project, you can directly delete the virtual environment, including every library that you installed there. And then sometimes you are working in Python and you need like a specific version of a library that works for one project and it doesn't work for another project. So in this case, you need always to have a virtual environment specifically to that project. So you can install, for example, a version of DICOM, which is 2.1, for example. And for another project, you need 2.8, let's say, for example. And so you need to have two different virtual environments, and each virtual environment contains one DICOM version. And the same thing for the other packages. So in this thing, and there are two ways to do that. There is the Python package, which is virtual environment, VN, that you can install and create virtual environments. And the second thing, which is Conda environments. For me, I prefer always using Conda environments. So if you don't know how, if you are not familiar with that, I can show you how you can install it. Otherwise, if you prefer using the virtual environment, so you can just skip this video because it is only about installing Conda and how to create new virtual environment in your PC. So to do so, you need just to go to the website here, which I will attach in this lecture. So you need just to go to this website, and for me, for example, I am on Windows, so I am looking here for the Windows installer. If you are in Linux or in Mac OS, then you need to go to that specific part. So let me just show you. If you are in Windows, you just need to take one of these. For us, I prefer always using Python 3.8, so you need to install this one. If you prefer using Python 3.10, then you can do that. For me, I always used to do Python 3.8 or 3.7. But of course, some projects doesn't need this specification. You can need any Python version, but others like needs always like Python 0.8 or Python 3.7. Okay, so for example, let's say that we will use Python 3.8. Then I need to click here to download the file here, the installer. Okay, so it is being downloaded. Okay, now it is here. And the same thing as I told you for the VS Code. For me, I have already the Anaconda or Miniconda installed on my PC. So I will not reinstall it again, but I will show you the steps. So you just need to click here 2 times to open this installer. Click on next. Then I agree for the terms and license. And after that, just for me or for users, you can just you need to click for you if you are only using it for yourself. Then after that, you choose where you want to install it. For me, I always leave it by default. And then next. But for me, I have it already, so I will not choose this. I will not complete the next step because I have already this folder and I have things inside it. So for you just need to click on next and you complete that, and all the installation will be completed and you will get it in your PC. What I can recommend you after doing this, let me just close this here. If we open like Anaconda prompt, which is this one, you need to open this. So when you open it, you should have here base. If you don't see the base here inside your path environment, meaning that it is not initialized. So what you can do, you just need to reboot your PC. So if you reboot your PC, you should have it here. If you don't have it there, you can just leave a message or in the community, or you can leave a message inside the lecture, and I will see that. I see how to help you with this. So you need to see here the base, meaning that Anaconda is installed and you are in the base environment. But for us, since I said we don't need to work on the base environment, we need to create a special environment for us. So to do that, let's just create an environment. And to create an environment, you need to run the command, which is conda. Let me just make it bigger. Okay, so conda and then create, and then -n or -name. You can put anything you want, like both of them works. So -n, which is the name of the environment. So here you just need to put the name of the environment. Let's say DICOM N, for example. And then if you want to specify the version of the Python that you want to use for this project, then you can just put Python and then equal, and then you specify the version. So for example, 3.8. So here it will create a new environment, virtual environment called DICOM env with the Python version installed 3.8. So you click just on, you just click enter and it will install. Click on yes. Now it is creating the new virtual environment with the Python 3.8.16, as you can see. Now it is installed. You need to activate it so that you will work inside it, because until now we just created the environment, but we are still working on the base environment. And it is giving you the instructions here. So if you want to activate it, just need to click on conda activate. And then the name of the environment, which is DICOM env, which is this one. Okay, so now it is installed. If, for example, you install you create an environment, but you don't remember, for example, you don't have anything here about that environment, and you don't remember what is the name of the environment that you created, you just need to click to use this command, which is conda info dot 2 dashes and then envs. Here it will give you all the conda environment that you installed in your PC. And for you, if you are new with that, so you will see only base and another environment, which is yours. And here you will get the name so that you can activate it. Okay, so this is how to create and activate the conda environment. in the next videos, we can start installing the Python packages that we'll use in this course. See you. Now in this video, we are gonna install the packages, like the Python packages that we'll use for the project. So as you know, like all the things like for DICOM, for NIfTI and all these things, like all these packages are not installed by default with the Python package. So you need always to install this library independently and you use them for your code. So to do so, let's go to our Conda prompt, like which we installed in the previous video for Anaconda. But if, for example, for you, you are using a virtual environment, so you can open your command window and activate your virtual environment, and then we do the same thing that we are going to do now. For me, I am opening it because I am using Anaconda, so I am using Anaconda prompt. I activated the virtual environment, the Conda environment or virtual environment, you can call it like that, which is DICOM amp that we created in the previous video. Now we can start installing the packages. So the first package that we will need, which is the most important one, which is PyDICOM. So to install a package, like just we need to put in pip install and then the name of the package, which is PyDICOM, which is this one. So this is the most important package in this course. So we'll just install it, click on enter, and it will install it. So now it is installed. If you want to check if the package has been installed correctly, so you just need to put like Python, you enter to the Python in your terminal, and then you need to import it. So for example, import PyDICOM. So since it is imported, meaning that it works well, otherwise there is a problem. So if you want to check if another package is installed, for example, the package nibabel, which is for NIfTI files. So I will try to import it. And you see that there is a problem because it is not installed. So we can do the same thing. We can just click on, you can just put exit to exit the Python part. Here we empty the terminal. Now let me just install the next package, which is nibabel, that we may need in this course in some point. So pip install nibabel. Yeah, and it is installed. Now let's do the same thing for the others. So for example, for numpy, so pip install numpy. It is already installed. The next thing, which is below, which is for image analysis library. So we'll use it for the conversion from DICOM into PNG or JPEG images. So we need always below or OpenCV or any library of these to do this conversion. It is not about the conversion, but it is about saving or exporting the file or the NumPy array into an image. So we will use below. So to install it, just need to put pip install below. And it is being installed. It is installed here. And the next thing that we need, which is OpenCV, which we import like CV2. But as you know, when we install it in Python, it is not like the same other packages. So I will just show you. If you want to install it, you need to go to because to install it, like to put pip install OpenCV Python, like specify to Python, but just to see, like install OpenCV Python. So here you see that it is pip install OpenCV-Python. We don't need to put only OpenCV or CV2 because it won't work, but you need to put everything here. So let's just copy it, for example, and go to the terminal and click here and install it here. Since OpenCV, like, it is a big library, it may take more time than the others, but you see that it is always fast to do that. So to see if the file has been installed correctly, let's just try to import them. So Python import PyDICOM, it is imported. So let's import numpy. If we want to import below, here there is something that you need to know. You cannot put import below because it is not like that. We installed below, but when we use it in the code, you need to import PIL. Because I don't know why they are doing like this, but you cannot import it like below. To install it, you need to use below because it's the name of the library. But to import it, you need to put PIL, which is the same thing for us, for them. You are importing below, but with different name. I don't know why, but it's like that. And the next thing that we installed, which is OpenCV, so import CV2. And the same thing we imported, we installed it OpenCV for Python, but we import it as CV2. It is like that. So this is how to install these packages, which are very important for our course. So I am importing them, I'm installing them now, so that the process for the coding will be easier. But if you need any, or if you have any problem installing these packages, please just text me, or you can just leave a discussion in the community or leave a comment in this lecture, and I will try to help you with that. See you in next video. So now let's start doing the coding part. The first thing that we are going to do is how to read a DICOM file, and then we go to the next steps. So to do so, we are going to use the VS Code that we installed in the previous videos. So at the beginning, when you open the VS Code at the first time, it will be something like this, like a new window, fresh window. There is nothing there. So you can either create a file or create a folder. For me, I always prefer creating folders because it will be only one folder, which is one workspace for all the projects. And you can put all your Python scripts, data, everything inside that folder, and it will be only one project. It is like a GitHub repository. So to do so, you can go on File and Open Folder. So when you click on Open Folder, you go to choose where you want to create this folder, or if you have already created the folder, then you need just to browse to it. So let's go to desktop. I want to create in desktop. It will be easier for me here. I will create a folder. I will put it, for example, DICOM course workspace. Okay, now we have the folder here, DICOM file workspace. Then, but until now we don't have any Python script or something where we will write the code. But before that, I need to have a DICOM file so that we can use it for our experiments. To do so, I am creating, or I am putting here this file, which is a DICOM, which is a slice. I just took it from a dataset. We will use it for now, but after that, we'll need a whole patient or a whole scan. So we'll have multiple DICOM slices. For now, we will use only this one, but after that, we will use the others. But for me, since I want always to organize the workspace, and I recommend you to do that, you need always to just, you don't need to put everything inside one folder. So for example, this file is like belongs to a data folder. So preferably you need to create a new folder and you give it a name, for example, data, and you can put all your data inside this folder. This will be easier for you to organize your work. Okay, so now I am putting it here, but if you prefer putting it directly in the workspace, you can do so. If you want to leave it in the other folder, you can do so, but you need to specify the exact path name. Okay, so here is the file that we have. If we go to our workspace in VS Code, you can see that we have the new folder data and the slice inside it. Okay, now let's start doing the coding part. So there are two ways to do so. The first way is to create a Python script, which is .py to do that. But for the course purposes, I prefer using Jupyter Notebook file, which divides the code into like multiple cells, and you can run each cells independently. So this will be easier to explain things. But if you prefer using Python scripts directly, you can do so because it is the same code. Only the way of writing it is different. But okay, if you want to do the same thing we're using Jupyter Notebook, also there are two ways. There are three ways actually. You can use either Google Colab, or you can use Jupyter Notebook extension that will open another text editor Jupyter Notebook different than this. Or you can install a Jupyter Notebook extension inside VS Code that you can use directly for the your project. Okay, so to do that, if you want to install Jupyter Notebook extension, you need to go to extensions here and search for Jupyter Notebook extension, which is this one. For me, I have it already installed. So I don't need to reinstall it again, but for you, if you don't have it, just need to click on install and it will be installed to your project. Okay, now let's just close everything here. After installing Jupyter Notebook extension, you need to go to this workspace, because if you click here and try to create a new file, the file will be created inside the folder data. But since for us, we know we want to create it inside the whole workspace, which is here. So you need to click on the workspace, then create. For example, if we want to have a new file, new folder, or refresh things, or anything like that. So for us, we want to create a new file, which is a Jupyter Notebook file. So click on new file, and let's give it, for example, name DICOM handler, let's say, and then you give the extension. And as I told you, if it is a Python script, you need to put py, which is py for the Python. But for us, if I want to create a Jupyter Notebook file, so I need to give the extension of Jupyter Notebook when creating the file, which is ipynb, Jupyter Notebook, ipy notebook. Okay, so here is our notebook now. Now here you can see, I don't know if you are familiar with this, but if you are not, there are two types of cells that you can create. There is the code cell, which is this one, and the markdown cell. Markdown cell is for the text. If you want to put a text, heading, titles, anything like that, to explain what is happening inside the cell or what is happening inside all the code, you can create a markdown and put everything there. But if you want to create only code cells, so you can just click plus 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 and you can add more. So let me just delete these. At the beginning, let me just create a markdown here for, like, there is hashtag for the first header, 2 hashtags for the second header, which is a subheader, 3 hashtags meaning the fourth subheader. So for me, I will just put 2, which will be not big text and not small text, but I will put here, for example, the title for the next cell, which is, for example, importing the libraries. Okay. For now, since we are going to only read the DICOM file, then I will not import all the libraries. I will import only PyDICOM, which what we need for now. So I always recommend this. If you are going to use at the beginning only one line of code that requires only one library, then import only that library. And whenever you need something else, you can import the other things. That's what I prefer. So, but it depends to you how you are doing this coding part, but I prefer using that. So now let's import the PyDICOM library. So import PyDICOM, which we have installed before. So if it won't work, you can just put that in the chat and I can help you with that. Now, if you want to run the cell, once you have completed the coding part in that cell, you can either click here, or so if you click here, meaning that you will run this and go to the next cell, which is the below cell. But if you click here, meaning that you will execute or run this cell and go to the cell before. So you can either use this or this, but the best way to do it for me is to click on Shift Enter. So if you click on Shift Enter, you will run the cell and go to the next cell, which is this one, for example. So yeah, we have imported the file, we have imported the library. Now we want to read the DICOM. So to do so, let's create a variable to take this file. So for example, DICOM file, okay? Then we need to use the PyDICOM library, which is PyDICOM. That there is the function DCM read, which is this one. So this DCM read is the function that will upload, or the instance that will upload or read the file. So for us, the file here is inside this folder, which is data. So you need to give a string here. Let's say data, that's then the file, which is slice, that's DCM. Okay. Now let's try to read it. You see, there is no problem. If I want to print it, for example, you can just, if we want to see if it has already been read correctly, so you can put DICOM file and run the cell. You see that you will have directly, because if you run directly the the file that you have read, which is the DICOM file. If you run it directly, or if you print it, you will get the metadata directly. This is what you will get, all the metadata of the file. Okay, so this is how to read the DICOM file and how to check if it is run and how to print directly all the metadata. In the next video, you will see how to take each metadata if you want to specify this one, if you want to modify it, or if you want to do other things. So see you in next video. Now, after that, we read the DICOM file, and here we printed all the tags that are available in this DICOM file. They are the same tags on all the DICOM files, only the values are different. So now let me show you how you can, if you want, for example, print a specific tag or specific information from this DICOM file. So let me just show you how to do so. Here there are three dots, meaning that there are other information that are here. You can find everything in the documentation, and I will also put this for you. And all this information will come later. Now I will just show you, if you want to show only one of these, I will show you how you can do that. But for all the available information, I will show you this in the next videos. But for now, I will just show you how to access one of these, and you can apply it for all the tags. Okay, so for example, here we have the image type. If, for example, someone needs this information, which is image type from the DICOM file, and wants to print it, for example, or yeah, if you want to print only this image type, or if someone needs to see the, let's say, patient name, patient ID, anything of these tags, like starting from these dashes here. So all these tags, and there are others here which are in the middle, they are hidden, but they are available, that I will discuss them in the next videos. But if you need only one of these, for example, study time or something like that, if you want to do that, you can just for example, we have the DICOM file that we created, which is the name of the variable, which is DICOM file. So here we have DICOM file. Then if, for example, we want to print the patient name, so let's just put patient and then name, which are all these tags, for example, patient name. So here, if I print it, you see that it is anonymous because this file is already anonymized, but you can do the same thing for, if it is not anonymized and you want to anonymize it, you can change these, but all these things will come later. So now, for example, this is the patient name. If we want to print, for example, the patient ID, so you just need to put the patient ID, okay? Because the idea here is to take this tag here and just delete this space, for example. So for example, if you want to print this, so you just need to copy it, for example. This is the tag that we want to show. And then let me just delete these and put it like this. And we won't need this this S for physician's name, but just referring physician name, and everything here are the same word, and all the new words are in the upper case. Okay, so let me just show it, and for this it is an empty string because it's also anonymized. So when we anonymize a file, we can either put it an empty string or we can give the name anonymous like this. It depends to you what you want to put, but these are the most common ones. Like only yes, you can have like empty name, there is nothing in the name, or the word anonymous. So you can do the same thing for everything. So not only for the name of the patient or name of the physician, but even the information about the file. So for example, here we have SOP instance UID. So if you want to show it, you just need to copy this, for example, and let me delete this and paste it and delete this with this. Okay, and here is the information, the exact information that you have here. The same thing for others. For example, if you want to print this or this or this, all these informations, you can do them like this. So for example, now these are the information. Now if you want to extract the image, which is the pixel array that you have in the in this DICOM file, because in DICOM file contain all this information plus the image that we can visualize. Okay, so this image, you can find, you see here that there is a tag called pixel data. It contains something about the image, but it is not the same, it is not the exact variable that you need to use to extract the image. So this can be used when you are changing the image. So if you want to change the pixel data that you have by something new, or you need to apply something on that image, you use this tag, which we will discuss later, not now, but we will discuss this later. But if you want just to extract the image from this DICOM file, you will need to use something else, which is the pixel array, this one. Okay, so if I print it, you see that these are the values of the image. Now, for example, if I want to let's say, for example, I want to see the shape of this image, so let me just give it a name. So let's say, for example, DICOM array equal. Okay, now we can use this variable. So we have DICOM array, not this, DICOM array dot shape, like this, to print the shape. So for this patient, for example, the shape is 512 by 512, and it depends to each patient. It's not about the patient, but it is about the machine that has been used to take the scan. Okay, so for example, the machine for this scan it takes 512 by 512. You can find something that takes bigger than this and others taking smaller than this. Okay, so here is for this part, which is how to print any information inside this DICOM file if you want to print or show this image. For now, I am just showing you how to extract the pixel array and how to, if for example you want to know the shape or anything else. But in the next video, I will show you how you can visualize this image and how to do other things to this. So see you in the next video. And for the visualization of these DICOMs, there are two ways of doing it. There is the first one, which is the base way of showing the image, and there is another one which is like more sophisticated, that give you control to show or to change the opacity of the image or change the contrast or all these things. So in this video, I will show you the basic one, how to just visualize it, and then in the next video I will show you the best way, which I prefer, of doing it. Okay, because the basic one may work for some kind of DICOMs, but it won't work for everything. For this reason, I will show you both of them, and you can see for which one is the best for you. But I always recommend the next one, but let me just show you both of them and you can choose, because this is the purpose of this course. It is not just giving solutions, but it is giving multiple solutions available, and you can choose which one goes well for your project. Okay, so let me just create a markdown here. Let's say show image, let's say here, but let's put one, which is the first way, and then I will show you the second one. So show image. Now, to do so, we are going to need to use the NumPy library. So we need to import it here. For example, no, import NumPy as np. And you need always to run the cell in every time you change something in that cell, you need to rerun it again. So we did that. Now let's start doing it. So as we said, we have the image, which is this one. So what we need, we are going to need this DICOM array, which is the image. But it is if we see the type of this DICOM image. So let's put type and then here DICOM array. So if you just print it, you will see that it is a NumPy array, which is very easy to visualize if you want. But since this value, if you want to see the values of this image, you can understand things. So let me just put, there is a function in NumPy called unique. So this function will give you the unique values of, so for example, if you have an image having like pixels, like which, let's say if you have only zeros and ones, so the unique function of NumPy will return like 0 and 1, because you have only two unique values, which is the value 0 and the value 1. And if you have 1,000 value of pixels in that image, so it will give you 1,000 values. So all the unique or all the different values of the pixels will be printed here. So let's do that just to show you the different values that we have in this image. So np.unique. Okay, and here we put the image, which is for us, which is the DICOM array. Okay, so let's just print it, and you see here that it is There is minus, the minimum one is minus 1021, and the maximum one is 14 and 99. So you see that these values are not normal, and because it's an integer and say for with the 16 bytes. So if we want to print this, or sorry, if we want to visualize this image using the normal libraries such as Pillow or OpenCV, it won't work because these libraries takes images or arrays which are from 0 and 255, which are unsigned integers, 8 bytes. So we cannot use directly this image. We need to do some pre-processing on this so that we can visualize it. Okay, so this is what we are gonna do in this first part of this task. So the first thing, as we said, we have the DICOM image, which is this one. Okay, now before doing anything, we need to convert this image into float, because if we leave it as integer and divide it by a maximum or a minimum, or we divide it by anything else, it will be always an integer. So if we divide, like for example, because here, let me give you the idea here. To do this thing, to do this conversions, we need to normalize the image, which means that we need to put all the values that you see here, we need to convert them from 0 to 1. So the minimum should be 0 and the maximum should be 1. So if we leave them as integers and we divide, so we'll have values only zeros and ones. So the image will be different than what we want. But we need to convert them into float. So if we divide them by anything, we can have values between 0 and 1. Because we don't want values zeros and ones. We want values between 0 and 1. So we can have 0 0.1, 0 0.5, 0 point something until 1. For this reason, we need to convert the image into float. So this is the first thing that we need to do. Here is how to do it. So for example, float DICOM file or DICOM array, let's say. You need always to give the name to your variables as the same concept that you have, so that you will not forget what is the role of this variable. So for us, it is float DICOM array. So I am giving it like that. Now to do so, let's just get the DICOM array, which is this one. But we used a function called asType, and then we give the how do we call it? We give the type that we want to convert. So in our case, it is a float. So we just need to put float. So now the type is float. If we run this cell, meaning that this image, this image that we had, which is the array here, it was a integer. Now it is a float because we converted it into float. Okay. Then what we need to do next is to do the normalization. Normalization, which is to have values between zeros and ones. So to do so, let's just do, because here, the second thing that you see, we had values between minus 1000 and something and plus 1400 and something. And in an image, a normal RGB image or grayscale image, we cannot have negative values of pixel. So we need to convert everything to positive values, which means we need to leave all the positive values as they are, and we replace all the negative values by 0. So everything that is minus something should be go to 0, and everything like plus something should be as it is. This is the first thing. So to do so, which is like, for example, let's say positive DICOM array. I am just doing it like this, line by line, just to show you how to do that. But in reality, if we want to do like a simplified and easy Python code, we can put all the things that I am doing here and it at one line. But since we are doing the course, I need to put everything in different lines so you see the steps that we are doing. But of course, at the end, we can convert all this part into one function that we can use for other things, which will be easier than putting everything like line by line, okay? So here we have positive DICOM array. So to do so, we need to use a function called np, which is numpy.maximum. So this function, the maximum, so it takes two parameters, for example, and whenever, for example, let's say a comma b, for example. Okay, so here what happens, it sees the values of the array a. So if the value, because this one is an array and this one is a value, so for example the array here, which is this one, and the value is 0, for example, so everything in this array less than the value b should go to b, and everything like bigger than b, let's say it will stay like it is. So the same thing for us, since we are trying to have something positive, so this b should be 0. So everything less than 0 should go to 0, and everything bigger than 0, it stays like it is. So everything is positive here. So what we need to do, because here we are eliminating the negative values, we are not like using the absolute value or something like that, but everything like smaller than 0 or less than 0, it goes to 0. And everything bigger than 0, it stays as it is. And for us, the array that we are using, which is float DICOM array. Sorry, float DICOM array. So here, everything in this float DICOM array less than 0 goes to 0. Everything bigger than 0, it stays as it is. Okay, so let me just run this. Now, if we want to run the numpy.unique, so numpy.unique, and we do the same thing, but here in the positive DICOM array. So if I run it here, you see that the minimum value is 0. The maximum value is 1000 something. It is always like that. But you see that the minimum is 0. You see? So now we don't have any negative values. The next step, let me just delete this. The next step that we want to do is to convert the values or normalize the values between zeros and ones, between 0 and 1, sorry. So to do so, since they are already float, so there is no problem, we don't have any negative value, so we just need to divide by the maximum. So what does it mean? So if you have, for example, an array, like for example 0, 4, 6, 5, let's say 1, 6, something like that. So if I tell you that I want an array, this is the array, the same array, but I want it normalized. So all the values which are inside this array should be between 0 and 1. So if you want to do that, if we divide everything by 4, meaning that this value will be between 0 and 1, this value is between 0 and 1, this one is between 0 and 1, but this one, no, because 5 divided by 4, it is 1 point something. So it is bigger than 1. The same thing for this. So if you want to normalize it, you should always divide the whole array by the maximum value of this array, which means that the maximum or the bigger value inside this array will be 1. And everything less than that will be 0, will be between 0 and 1, because it is not bigger than the maximum. This is how it happens when we do the normalization. So we'll do the same thing here. We have, let's say, let's give it another variable. But as I said, we can put everything in one line, but I am dividing it like this so that we understand the steps. So normalized DICOM array. Okay, now what we can do is to use dividing the function by this positive array by the maximum. So what we can do is positive DICOM array divided by the maximum, which is the maximum of the same array, which is positive DICOM dot max, like this. So now what we are doing, we are dividing the positive DICOM array by the maximum of the positive DICOM array. So now let me run this. If we print now the numpy.unique, let's see. So we have np.unique, and then we give the normalized like this. So now you see that the values are between 0 and 1. The maximum value is 1 and the minimum is 0. Here we have 9 point something, like, but it is divided by 10. For this, it will be 0.9 something, which is less than 1. So this is what we need to do. This is at the beginning what we have to do. But also, this image is always not ready to show. So it is like a float between 0 and 1. So it is not ready for the visualization. But to do so, we need to convert it into values between 0 and 255, which means that we have an RGB image. So this is one step. There is another one, but this is one step. So to do that, we just need to multiply it by 255. So since the value, the biggest value is 1, so the biggest value will be 255, like the most white pixel, and the less, like the smaller value will be 0 by, we multiply 0 by 255, which will be 0, so it is always black. I hope that you got this. If you have any questions about these, please leave them in the comments, or you can just put them in the community and I can see how to answer you and explain to you how it works. Okay, so yeah, this is how we do this part, but let me just show you how to do the other part. As I told you, we'll do the same thing. I will not create a new variable, but I will just store it here, like normalized DICOM image multiplied by equal multiplied by, and we put the value that we want to multiply, which is 255.0, which is a float. So now what we are going to do, we are multiplying the same image by, so we are having like this line, meaning that normalized DICOM array equal normalized DICOM array multiplied by 255. So the same thing is here. So let me just run it here. And if I print the unique, you see that the maximum value is like 2.55 multiplied by 100. So it will be 255. This is the maximum value. And this is the minimum value. But also, this is not always ready because, as I said, to show an image, it should be an integer. And now it is still a float. So to convert it into unsigned int integer 8 bytes. So we can use this function, which is like, for example, let me use the name unsigned integer 8 bytes. So, and image. Here, what we can do, like np, there is the function np dot unsigned int 8. And here you give the array, which is normalized DICOM array. So here, if I do that, now let me just print this numpy, and now you see that we have values between 0, 1, 2, 3, 4 until 255. So this image now is ready to be visualized. But to do that, we are going to need the help of the pillow function, the pillow library that we installed. But before that, we need to import it. So here there is a class called image inside pillow. So we can import it like from PIL. PIL is the same, is pillow, but we don't import it as pillow, we import it as PIL. So from pillow, import image, which is this one. So this is the image. Maybe you are asking how the code or how VS Code is proposing to me a lot of things here. It is not the same as if, for example, you put image dot something. If you put image dot something, it will just show you the functions and the instances and the variables that are inside the class. But here you see that the code is proposing to me how to complete, the VS Code proposing to me how to complete the code. So this is due to a extension called tab9. I installed it for free. It is just here in the extensions. You can just search for it and install it. It will help you a lot when you're doing your code, and it will speed up your work. Not all the time. Sometimes it gives you something wrong, but most of the time it will help you. So maybe if you are asking how to do that, you can use it here. Okay. So now we just imported image from pillow and I run it. Now we will use it for our visualization. But before that, we need, because here it is still an array, numpy array. It is not a image. So to do that, we just need to convert it into image. So let me create another time pillow image. And now we use the image that we created, that we imported. And here there is the function from array, this one. So this function from array will take an array and convert it into image. So from array, and we put the uint image. Okay. Now we have the new image. Now we can do anything we want. We can save it, visualize it, anything we want. Now let me just show you how to do that using pillow.show. So pillow image.show here. Now we should visualize the image, which is this one. So you see, but here for this case or for this DICOM, you see that by default the image is not well visualized. It needs some adjustments in the contrast. But while using this kind of functions, or this first step for visualization, as I said, it is the basic one. You don't have control to the contrast, so you can just show by default what is looking like this. But I will show you in the next video how to do this visualization, but with more sophisticated way, and how you can get control on the image and you can visualize it like better and better, and depending to which DICOM you have. So I hope that you get this. And I am not saying that this way is not good, because for me, I was using this same way for some projects and it is very easy and it works. But in some kind of DICOMs, it will not work. For this reason, I am presenting to you both of them, and you can choose the best one for your project. So I see you in next video. Now, after that, we completed doing the visualization using the first approach that I shown you here. Now let's go to the next one. After completing both of them, we will do a video of how to organize these things and put them in a function that will be easier to use for other things. But for now, I'm just showing you details, but after that, we will organize everything. Now, let me just create a new markdown. So here, let's call it show image, but 2, which is the next step, for example, or next approach. Okay, so the first thing that we are going to do is the same approach that we used for here, but the things that will be different are we are not going to do the conversion into float or anything like that. We just need to do you will see that it looks similar to what we did, but the tricky thing is that this will be easier if you want. This will help you, and it will be easier to change the contrast of the image if you want. So let me just show you how to do this and where we can change the contrast of the images using the same variables that we'll use now. Okay, so the first thing that we need to do is to define a House field minimum and House field maximum. What does it mean? Like, we are just selecting the minimum value, pixel value inside the image, and the maximum pixel, which we should call actually voxel, not pixel, because they are 3D pixels. So a 3D pixel, like the pixel that has depth, we call it voxel, not a pixel. So we need to define this minimum value and maximum value. These are the first thing that we need to do. Then we go to the next step. So the minimum value is, as you remember, when we use something like maximum, so we use something like this, but we will use now minimum and maximum for this purpose. So which is, for example, let's say that house field and min for the minimum. So it is equal to, let's find the minimum value. So np, which is numpy.min, it gives you the minimum of the array that you will give. So numpy.min and the array that we have, which is for us, this is not the array, but the array is this one, DICOM array. So the exact array that you will extract from the DICOM file is the one that you will use. So you just use this DICOM array that you extracted from the DICOM file that you read. So DICOM file, you read it, you extract the DICOM array, and you use it directly here. So here we are calculating the minimum. So if I do this, let's say house field min. So if I use this, you will see that this is the minimum value of this slice. And the same thing for the max. So let me just copy this. I started using the easy or the lazy way of doing this. So the max, and here the max. Okay, so now we have the minimum and the maximum values. And another thing that we are going to need is the range between these two. So the range is always, when we want to calculate the range of an array or something, or two values, we have the maximum minus the minimum. So that's what we'll do. So here we have house field then range, for example. So it is like the maximum minus the minimum. So house field max minus the house field min, something like this. So since the minimum is already a negative value, so it is like having the absolute value of the max plus the absolute value of the min, because minus minus it will be positive, but we should not touch this for now. We should leave it like this. I will show you why, and it will be this is the part, because you should focus on these three things. These are the three variables that will control the contrast, so you should always put them as like the most important thing to change the contrast of the image. So now let me just run this cell and leave them here. Now what we are going to do, as you remember, for this part here, we were calculating the maximum between the voxel values of the array and 0. So we were replacing all the negative values by 0. But now we are not going to do that thing. So the idea here is to put like everything less than the minimum into the minimum, and everything bigger than the maximum into maximum. I know that it will look like strange, like since we have the minimum, we cannot put minimum, we will not have like something smaller than the minimum, or and we will not have something bigger than the maximum. This is how it looks. So if I have an array having like let's say 1, 2, 3, 4. So I cannot, in this array, the minimum is 1, the maximum is 4. So I cannot apply like a condition like if we have something bigger than 4, then replace it by 4 or something, because we know that the maximum is 4. This is how it looks. But the tricky thing is this. For now, when since we are using the minimum and the maximum, the exact values of the minimum and maximum of the array, it won't change anything. But in the next step, you will see that this is the tricky thing, and this is how you can control the contrast. Now, let me just run it and show you this minimum and maximum thing, what it shows. But after that, I will show you what is the tricky thing to change the contrast. So let me just delete this. So as I said, like we need to have the minimum. If we have something less than the minimum, then it should be replaced by the minimum. And if we have something bigger than the maximum, then it should be replaced by the maximum. So we have DICOM array. So everything inside DICOM array less than the house filled minimum should be replaced by house filled minimum. And the same thing for the maximum. So DICOM array, everything bigger, and you see here this tab 9 is helping, but I just wanted to mention that. So you see that when we have the DICOM array bigger than the house field maximum, then we replace it by the house field maximum, something like this. Okay, so you see that it doesn't mean anything now, since this house field is already the minimum and house field max is already the maximum. Okay, but just let's be patient, and I will show you what is the tricky thing. Now we need to normalize the image, the same thing that we did here, but here it will be a little bit different. But let me just call it normalized image. Let's call it 2, for example, to differentiate it from this one. So let me call it normalized image. It is not image for now, it is an array. So normalized array 2, for example. Okay, now what we need to do is to divide the image by the maximum. But the problem here, if we just divide it by the maximum, we will have always the minimum value. So the idea here how to do this is to like let's take the array and do minus the negative, meaning that minus the minimum, sorry. So if you have like 1 minus, and then here you have -1, for example. So this means that you will have equal 1 plus 1. This is what does it mean. 1 minus -1, it should be 1 plus 1. This is how it looks. So the same thing what we are going to do, like we do the array minus the minimum value. So it should be like the array plus the absolute value of the minimum. This is how it looks. So we are going to do that. And after that, we divide by the range, which is this, which is the maximum minus the minimum, which is the maximum plus the absolute value of the minimum. So now let me just show you how to do that. So normalized array. Now it is like the DICOM array, which is this thing, because here the DICOM array, which is already replaced by these, by this condition. So we have DICOM array, which is this one, then minus the Hounsfield minimum, so Hounsfield minimum, and then we divide it by the Hounsfield range. So we are dividing it by this so that we can get the values between 0 and 1. So this is almost the same that we did, but only the idea is different. Here we are dividing, only taking the image, dividing it by the maximum. But here we are taking the image minus the minimum, which means we are adding the minimum. Then we divide this by the range. It looks similar, but it is not. If you test it, you will see that there is something different here in the values, okay? Especially for the next step that I will show, because until now it is almost the same, but in the next step you will see that there is a difference, okay? So yeah, now let me just do the next step, which is, since we have already the value that we have now, we need to multiply it by 255, the same thing that we did here, and we need to convert it into an unsigned integer image, 8 bytes. So here, let's do the multiplication first. So we have normalized image2, then multiplied equal to normalized image2. This is how to do that. And the next step is to convert it into unsigned integer 8 image, but we add 2, for example, just to differentiate it from the other one. So equal, then the numpy dot unsigned integer 8, and then here we put the normalized image 2. Okay, so now we have the new normalized image 2. To do the visualization part is the same, so I just copy this and paste it here and replace this by this. So here we have 2. Okay, now if I show the image, there is something that I didn't expect. Let me just see, where is the problem here? Sorry, I should multiply it by 255, not I multiplied it by the same image, which is not normal, so I should multiply it by 255 so that I get values between 0 and 255. So let me rerun the cell again and show it here. So you see, this is the image by default, and it is looking way better than the other one. Let me leave it here and run the first image again, just to show you. So this is the first image, and this is the second image here. You see, now it is looking better than this, but we still can do the modifications. So to do the modification, the only thing that we need to touch is this part. This is the most important part. So if we touch this minimum and maximum values, this will control the opacity. But the idea will say that why or how can we control this? How can we see that this is a good value or not? So for this, I will show you something in another software just to explain to you how it works. So let me open ITK Snap. I don't know if you know about it, but it is like for visualization and annotation software. So let me just open, this is the same slice that we are using here. So if I open it here like this, here is the slice. So if I want to play a little bit with the contrast, you can go to image contrast, adjust contrast. Let me move it a little bit here. Okay. So if I play with these values, which is the minimum and the maximum, if I play with them here, you see that I am controlling the contrast. And I found that the best values are minus 200, and the best here is plus 200. So these values, I found that it shows a lot of information, and you see all the texture in the image looks good. Most of the scans that I used, I found that these two values, the minimum minus 200, maximum is plus 200. I found that these are good values. But of course, it may change for another scans. This is only to show you for this course. But if you are doing something different, then you need to change these values until you get the best values for your data. So you see here, now, since we can control these and you can see everything in the image, you can, for example, if you want to see the best value in that you can apply for your function, you can see this here, you can see, and you can take these values for your thing. So you saw that minus 200 and plus 200 was the best values. So let's apply this in our code. So you may not need another software to do that. So let me just show you how you can do it. Now, as I told you, these are the minimum and the maximum. So if you change this minimum and this maximum, it will give you the exact opacity or the exact contrast that you showed, that you saw in that software. So let me apply it here. Let me just comment this and comment this. Okay. Now let's give the value for the minimum. We said minus 200. And for the maximum, it should be plus 200. Okay, so let's rerun it again here, this and this. And now you see that the image like this here, you see that the image, the same slice, but we changed the minimum and the maximum. You see that it is looking way better and the texture is more clear in this visualization. And you see that the same values that you saw in that software, we apply them here, are the best. And you can always play with these values and see something good here. So this is how to do the visualization, because you remember using this first approach, you don't have control to anything in the contrast of the image, but using this only by changing these two values, you can do a lot of things and you can visualize the image way better than the other one. So this was how to do the visualization. We can see all these things later, and especially in the course project where we will build an application that you can use for your projects, and this application can do the visualization, and of course you can always adjust the values of the contrast, for example for the min and the max. All these things you can have them in the application, but all these parts will be at the end of the course and it will be like the bonus of the course. So see you in next videos. Now, after that we have done this visualization, so we are just taking the DICOM file that has been read and we are visualizing it. Now, if you want to make the code more sophisticated that you can use after, so here I will show you how you can do that. Like we will create a function that directly takes the path of the DICOM file and does everything. Like if you want to use it for visualization or if you want to use it for something else. So to do so, let's just create a new cell here and start copying things. So let's call the function, for example, def and visualize this DICOM, and let's give it the word the number 1, meaning that this is for the first approach, and then we'll create another one for the second approach. Okay, so for this one it will take the DCM file, for example, the path to the DICOM file, and then here we will put everything. So I don't want to write the code, but I will just copy and paste the code so that you will see where we can put the file, where we can put the lines that we created. So what we need to do, the first thing is to read the DICOM file. So I will just copy this, and here we need to read it. So we have read the DICOM file, but the only thing that will change here, instead of putting this path, we will need to use the DCM file path that we have in parameter here. So this is how to read the DICOM file. Then we need to extract the array from it, which is this one here. Let's take this and go to our function here, and I will put it here. So you see the DICOM array, it is the same lines that we are using. I'm just copying them and pasting them here. Then after having the DICOM array here, we need to do the same thing as we have. So just copy and then paste it here. Just move it here at the same level. Now you are opening the DICOM file, you are extracting the array and the float and all these things. What you can do, you can like, instead of leaving all these things, you can directly make the code minimized. So when we are reading the pixel array, so now it is already a NumPy array, so you can directly convert it into float. When you extract it, you convert it into float. So you don't need this line. So let's comment it here. But you will see that this float DICOM should come here. So we need to replace it by this, because now this DICOM array is already a float. So we put it here. Now we are calculating the positive. We are getting the positive. But after that, there is something like we are calculating the positive and dividing it by the maximum. We can do that directly here. So we can put this here and we divide it directly by the maximum. So here we divide it by the maximum, which is this one. But the maximum, which will not be the positive, but it will be DICOM array here dot max. Okay, so now what we are doing, we are just taking the positive. Here it is positive plus we are normalizing it. So this line here, I will comment it, which we don't need. So we are reading the array. We are calculating the maximum between 0 and the array and dividing it by the max, which is the only one value. And then we are getting this. And this, I think we should not use it like this. We should rename it into something that means a normalized DICOM. So let me just use this as normalized DICOM array, for example. And this multiplication, we should take it here and multiply it by this, since we are doing everything at the same line. As I told you, we can do everything at the same line. So I am directly taking the maximum and dividing by the max and multiplying the results by 225. Then let me just delete this line. The same thing for these, since we don't need them anymore. So yeah, like this. Now you see that this is a small function having everything. It takes only a DICOM file and it does everything and it returns this. So now before that, we need to return it. So let's do return and you int image. Okay, so this is one way of doing it, but I always like to, for example, if we want to do visualization, I always like to include the visualization part inside the function. So this is the visualization part. If I take it and put it here, here we are including the visualization inside the function, but not all the time we want to do the visualization. So we are doing the visualization, but sometimes maybe you will need only normalization. You don't need the visualization. So we can do the normalization only and return this without any visualization. So if we want to do that, we can add a parameter here. We can call it, for example, show, which is a Boolean, which takes the value true, for example. Let's take it by default false. Just something like this. By default, it is false. So if show is true, meaning we want to do the visualization. Otherwise, we don't want. So to do that, we need to add a if condition here. So if show. So when we put if show, meaning that if show equal true. We don't need always to put if show equal true, but if show, meaning if show equal true, this is the same thing that if show equal true. So this is the same meaning. So if show, meaning if show equal true, do the visualization. Otherwise, we don't want to do it. We just return this as it is. Okay. So to test this, we can do it like this. I will add here. But as I told you, it is not only for visualization. It is for normalization only. So if someone don't want to do the visualization, he just do the normalization and return this. So maybe it is preferably to change the name of the function. So let's call it normalize. And so it is for normalization and visualize the DICOM 1, for example, for the first approach. Okay. Now let's try to test the function. Before that, we need to run the cell. So it is recognized. Now let's do normalize like this. Here we need to put, for the first parameter, we need to put the path to the DICOM file. So it is data and then slice.dcm. And if I just do this, it is just returning the file after doing the after having all the normalization, sorry, but we are not showing or we are not visualizing anything. So if you want to show it, you just need to put here show equal true. Okay, Now, if I run it, we can see this image, the same thing that we have for the first approach. And we can do the same thing for the others. So let me just, yeah, okay. We can do the same thing for this function. And yeah, let's create another function. And since now we have already this function, we can delete this and we can delete this because we don't need them anymore. We have this. This is how to do the this is the function, and this is how to call it. Let me just create a new, no, let's call it image image1, for example, so I don't get this this output here. I just wanted to do the visualization. I don't want the output here. Okay. If you want to use the file after doing the conversion, which is a NumPy unsigned integer 8 bytes, this is the one. It is stored to this variable. So let's do the same thing for the other. Here we have another cell. So let's do the same thing. So def normalize, and now let's give it the value 2. But the thing that will be different here, there are some conditions that we can add for these. So let's just copy this. Before that, we need to open the file. So like this. And this is the DCEM file that will be in the parameters. It should be the first parameter as always. Now let's take these, copy and paste. You see that now we are just organizing our code. So if someone is doing his code at the beginning, he can work as anything he wants. But I recommend, like, if you are testing something, you can test it. But once it works, you should always organize your code. I don't recommend you leaving everything at the end of your programmation of your project and then you organize the code, because it will be like a lot of things to change, and it will be lazy to do it. So I prefer in any time you completing. So for now, since this works, now we can organize it, and the same thing for others. I don't recommend to leave everything at the end. Okay, so here we have this part, but we can make a condition. So if we give this value, if it is a customized value, then we take it. Otherwise, we take the minimum, or the same thing for the maximum. Okay. So before that, we need to define them here in the parameters. So let's say max v equal, for example, none by default, and min v equal none by default. You see? So now if let's make the first condition. So if max v, here they are giving it is not none, but for us, since I said it is the same thing, then true and false. So if max v, meaning that if max v is not none, the same thing. If max v is not none, then we give the this house field min, yeah, no, here house field max. So we give the house field max the value max v, okay. And else, if I prefer doing it like this at the same line so that it won't look big, so I think it is preferably using it like this. Else, if it is none, meaning we didn't give a customized value for the max field, yeah, for the house field max, then house field max equal to the max here. Let me copy it like this, okay? And the same thing for the min. So if min v equal, if min v, then house field min equal min v. Else, then we use the same thing, like, which is house field min equal numpy dot min. This is this line here, like numpy dot min and the minimum of this array, which is the file that we read here. I think I forgot something, like I forgot to have the DICOM array. So we can do it directly here. So we are reading it and then pixel array. Okay, so you see at the same line we are reading the file and doing it here. We can do the same thing here if we want, but let me just put it here. I don't know if, okay, let me put it in another line so that we can respect the same way that we did for the other. So DICOM array equal, okay, DICOM file dot pixel data. So this is the DICOM array. We are using it for the maximum and for the minimum. If we are not giving a customized value for the min and customized value for the max, then let me delete this. We don't need it. So this is how to give the value of the house field max, house field min. After having them, you can directly use the same thing here, copy and paste, but here. Okay, let me just move them at the same level. Now we are doing the same thing. So we are reading the file, doing this, calculating it, and house field, everything is the same, okay? Now I can delete this because we are inside the function, so 1 or 2 doesn't mean anything. Normalized array, let me put it here. And yeah, okay. So you can see that normalized array, we are calculating it and then multiplying it. So we can directly multiply here. We can multiply it by 255, okay? And then delete this, we don't need it. And now we have this function, and we can do the same thing if we want, for example, to show. So we can add here the parameter show equal true, okay? Now, if show, we can do the same thing. If show, we can use this function, which is this one here. If show, then let's convert the array into below image and then show it. Else we just return the uint 8 image. Okay, so let's run it and do a test on it. So normalize image 2 like this. So at the beginning, and here I will initialize it. So for example, image 2 like this. So I am calling the function. So at the beginning, I will just leave it by default. So data, then slice dot DCM, okay? And I will show it. So show equal true, okay? So let me run it. There is a problem somehow. If show, sorry, here it is not a function. So like this. Now you see by default it is something like this. I think there is some kind of thing that need to be changed. Why it is like that? It should not be like that, because since I am calling it house field normalized array and below image is equal. Yeah, I think here I forget. It should be like this, because here we are using this image. I should not put it image 2. So let me rerun this, because since I am running it by default, so I am taking the max and the min. So it should look like the exact image how it is. So it should look like something like this. Even this is not the thing that I am trying to show. Let me see, because this is the problem when you copy and paste things. You will always have these errors. So I'm image normalized array, and then we are taking the image. Okay, let me try to change here. If we take max v, for example, equal to let's say 200. No, let me take it 1000 and see if it makes changes. And min v equal to minus 1000. Okay, so let's run it. And you see that it is the same thing. It is not being changed. I'm sure that I missed something here in this function. It will just come DCM. I am reading it. DICOM file, DICOM array. Okay. DICOM array. There is something that is not normal in this image. House field. There is something. Let me see. Something is not working correctly because if max v house field max equal max, else equal np dot max. There is something that I should see. I think I see here where is the problem, because here we are dividing by the range. And as you see, here we are taking the range min, we are taking the house field min and the house field max, but we are using the range of the old value. So here I am still taking this range, which is always these two values. For this reason, I am not able to see it. I am sorry about this. I have just saw this problem, but because you see, when you copy and paste things, you always forget some things. So I am just taking it here because we need always to update this house field range depending to the house field max and house field min. Now it should work. So if I run this, I will delete these to leave it by default. Now if I run, yeah, this is what we should have. This is by default visualization, the same thing that we had when we had the lines without any function. Now if I want to customize the contrast, so let me just put it like this. If I run it like this, it should not, it is something like this. Let me run okay, let me take for example 200 and minus 200. Okay, so now you see that it looks better. If I take something like 11,000, let's see, yeah, if we take 11,000, you see it is like that. So now we are customizing the contrast of the image directly using this function. If we give values, it will be customized. If we don't give, it will be by default, like with the blur, which is not clear. So here you can, when you do this, you can always control the contrast. So if, for example, you want to use this image for visualization, or if you want to save it as PNG or JPEG, which we'll come to it later. So if you want to save it, most of the time, if you leave it by default, it will not be clear, the same as we had when we left this by default, the same here. Or if we when we used this old function, which is this one, when we use this, you see by default it is like this. But if you want to customize it to your needs and you want to have like clearer contrast, then you can use this function, for example, and it will, you can play with these values until getting the best visualization experience, and then you can use these values for the savings. And for this reason, I put the function that returns this. So if you want to save, you can save this here. So I think here was just for organizing the functions. So we'll need them after, not now, but we will need them after. So this was how to organize them. After that, we can do something else. But for now, let's keep it like this. In the upcoming videos, we can save this image with the exact contrast as a PNG, JPEG, or anything you want. So see you in next video. Now, let's say that I want to anonymize this DICOM. So for example, if you have like new scans that you want to use for any data science project, or you want to share them with someone and you don't want to share the information of the DICOM, which means the information especially about the patients, the study ID, study date, all these things. So you need to anonymize them. So either you need to change all this information or you may change only some of them, but that's what we call anonymization. So you don't need to share the DICOM files, including the information about the patient or any about the doctors or anything like that. So to do this anonymization, it is very easy. I will just show you how you can do that, and then we can create a function directly to do that. So since we have already created the DICOM file at the beginning, which is this one, and we have this DICOM file which is already read. So if I put here DICOM file. If I print it, you see that we have all this information. So as I said, if we want, for example, to change the patient name, patient ID, we can choose some of this information. So for me, I will choose, for example, the patient name, the patient birthday, the study ID, and the patient sex, for example. And then if these are good for you, you can use them. Otherwise, if you want to change them, you can change them and take something like, for example, patient ID or referring physician's name or something like that. So let me just create a new markdown here. Let's call it anonymize a DICOM file. Okay. Now let's start doing that since we have already the file, which is this one. So what you can do if you want, so for example, let's say we want to change the patient name. So DICOM file dot patient name, which is like this. If we do equal and give another string, meaning that we are changing the patient name. So now the patient name was, from now it is already anonymous, but let's say, for example, I want to give it a name, for example, PYCAD. Okay, so now I gave it the name PYCAD. If I want to anonymize it, in reality, we need to put anonymous or we need to put it something like this, an empty string, okay? So for example, let me put it PYCAD just to show you that this patient name has been changed, and the same thing for others. So let's say for the patient birthday, sorry, DICOM file that let's say patient birth date. Okay, then we can give it something else. So let's say, for example, 1st January, yeah, for example, 199, for example, okay, 1991. And then if I want to change, for example, the study ID, so DICOM file dot here dot study ID, this one, okay. So we can give it something as like 1 2 3 4 5, something like this, 6 7, okay. And then, for example, let's change the patient 6, okay. So DICOM file dot patient 6, this one, okay. So for example, let's put it just an empty empty string. So if anything is in this tag, for example, let's see, I think it is already anonymous. Patient I think it is not here, it is in these dots, in the 3 dots, so it is here. I cannot see it, but if we want to show it, so let's just put DICOM file dot patient 6, okay. So if I run it, it is already anonymized, but let's just keep it like this, so that if anything, for example, for this DICOM, it is already anonymized, but for other DICOMs, it won't be anonymized, so you need to put it like this, okay. Most of the time, if you want to anonymize things, everything should be as this one, so it should be empty string, but I am just putting it like this because there are some, for example, the patient's birthday or something, it is already anonymized, so I am putting it like this just to see that the file has been changed in reality, okay. So if I do this like this, okay, we just completed it. So now if I print the DICOM file that patient name, okay, if I print it now, it is PYCAD, okay. But until now, the file has been changed, but it is still in the code, like it is only in the program. We don't have a file or a new file, DICOM file, that contains these new anonymized files, sorry, information, sorry. So if I want to save this new file, what we can do is just to use DICOM file dot save as. So this save as function will allow you to save this DICOM with the new information, and you can just give the path here. So for example, I will put it in data, and let me give it for example, anonymization anonymized slice .dcm. Okay, so now I have saved it. So here you see that we have a new anonymized file. If I want to see if it is really working, so let's say new DICOM file, for example, equal to PyDICOM. We will read it again and try to print this information to see if it has been really changed and saved correctly. So data slash anonymized anonymized slice dot dcm. Okay, so now I have loaded it. So let's print, for example, the new DICOM dot patient name, for example. Okay, so yeah, let's see, it is PYCAD, which is the exact name that we gave here. It has been saved, and when we load it, it always contains this information. So if you want to anonymize a DICOM file, you just need to read it and then change, for example, this information that I choose randomly. If you want to anonymize other information, you can just add them using the tags. Otherwise, you can just leave it like this. And after that, you save it with this function. Okay. So let's put this together in a function that can be used. So to do so, we need to create a new function. Let's call it def anonymize DICOM. Okay. Now it will take DCM file, and then the first thing that we need to do is to read the file. So DICOM file equal to PyDICOM. Then I will use it here, DCM file, so we don't get confused. So DCM file. Okay, so we are reading it. Now we need to start doing the anonymization thing. So there are two things, as I said. So the first one is to just put them into empty string. Otherwise, if you want to really put something which is different than the reality, so if the name is PyCAD, for example, if you want to put it something else like Joe or something, you need to assign it. For this reason, we need to give them in parameters of this function. So for example, if you want to change the patient name, then we say the patient name, for example. At the beginning, it is none by default. Okay, so let's say if someone wants to change the patient name, so if this someone that's used this function, if he give the parameter patient name, then we assign that parameter into the patient name. Otherwise, we just keep it as an empty string. So we can just use if patient name, then the DICOM file that patient name equal to pn. Okay, so if the user specifies the patient name when calling the function, then we give it to the not np but pn. Okay, if the user specifies the patient name, then we assign the patient name to this variable. Otherwise, else, we just put it as a DICOM file equal to an empty string. So if the user doesn't specify the patient name, but he wants already to anonymize the file, then we give a empty string to this patient name. And the same thing for the others. So for example, let's say the patient birthday, for example, pb equal to none. Okay, the same thing. And here, if patient b, then that's patient birth date equal to patient's birthday. Else, if the user does not specify this parameter, which is the patient's birth date, then it is equal to an empty string. And the same thing for the others. So let's say for the study, for the study ID. So let me just put st for the study ID, for example, and it is equal to none by default. And here, let's say if study ID equal to if the user specifies the study ID, then the patient, the DICOM file, that study ID equal to it's st. Okay. Otherwise, if the user does not specify this study ID variable, then study ID patient DICOM file, that study ID it equal to empty string. And the same thing for the other one, the last one, for example, which is the patient 6. So ps equal to none. Okay. And we do the same thing here. If ps, then we use DICOM file that patient 6 equal to ps. Okay, else equal the empty string. Okay, so this is our function. If I want to do the same thing, if I want to apply this anonymization, I need to give the path to the DICOM file, and it will be done. But until now, we are not returning the new anonymized DICOM. So we just need to return DICOM file. Okay. So if we want to include the saving part, then we need to do it directly outside the function. If you want to add the saving part inside the function, that you need to specify the path to the output. For this reason, I prefer not using it here. So this function directly, it will return the DICOM file, and I can use this part which is here. I can use directly this line to do the savings outside the function. But if you want to include it in the function, then you need to add a parameter here, special for, let's say, saving or save path, for example. It is equal to none. Okay, so if you want, you can do it like this. And for example, if we want to add it really in the function, so if someone gives if someone gives the saving path, so which means that he wants to save the file directly from the function. So we can add another if condition. So if save path, then we can do this this operation, which is the saving. Here we have the DICOM file that save as, and here we gave this save path. So if the user gives something to this function, so for example, now it is, let me just put it as false. This will be easier. So now it is false. No, yeah, so sorry, I did it wrongly. So because if it is false when we give it true, doesn't mean that the function contain the path. But now it is none, meaning that there is nothing given to this variable. But if we give a path to this variable, meaning that we want to save it, and it will be saved in this at the same path. So this was how to do the anonymization to a DICOM. If you have any questions about this, and the same thing as I said, here I just choose these 4 tags that I changed. If you want to change more than these tags, you can just add them here by DICOM file, that's the tag, and then you can specify which value you want to give. So as I told you, if you have any questions, please leave them in the comments, or you can put new discussion in the community, and I will try to answer you as soon as possible. See you in next video. Now, let's say that you want to change a specific tag in the image or in the DICOM file, because here at the beginning I am showing you how to just anonymize, which is but it is the same thing. Like, we are anonymizing, but in reality we are changing the value of the tag. And we can do the same thing for the other tags. It is not only about this specific tag, which is for the patient name, patient birthday, or something like that. We can do it for all the tags available in the DICOM file. But the idea here is, is it easy to do it, or we need specific things when we are changing the variables? So as I told you at the beginning, because there is this part which we cannot change. I tried changing it, but I couldn't. So the thing that I could change was from here, from the image type, and after that, all the tags that can be available after this image type tag can be changed. The others, I couldn't change them. Maybe I am missing something, but for me, these are the tags that I could change. Okay, so to do so, let me just show you how to do it, because it is the same thing then that we are doing for the anonymization, but it will be just a different function. So I will show you how you can do it for one tag, but for the others, because it will take time if we write all the lines for all the tags. But I will show you how you can. I will just give you the code that I have already written, and you can use it. And if you don't understand anything on it, please let me know. But you will see that it's the same thing. Let me just create new markdown here. For example, let's give it the name changing tags, for example, like this. Okay, so the function will be def then change tags. Okay, the first thing that we need to give is DCM file, which is the path to, which is not DICOM but DCM file. Okay, which is the path to the DICOM file that you want to change its tags. Okay, why I am giving it, so if someone of you wants to change the information of a DICOM file, or for example, if you have a database that contains a lot of like thousands of DICOM files, and you have, for example, an XML or TXT file containing the information of a DICOM that you want to change, so you can use this function. So this function will allow you to change any tag inside a DICOM file. And of course, since it is a function, you can call it multiple times inside a book, inside a for loop. So when you call it inside a for loop, then you can directly apply the same operation for all the DICOM files available in your database. Okay, so for example, let's say that I want to change the image type. So here we have image type. So I will give the same typo for this variable as the tag that is available inside the DICOM file. So let's by default put it as none, meaning that at the beginning, if the user doesn't want to change the image type, then it should always be none. Otherwise, if the image type is given, if image type is given, then we change it. But before that, I forgot to add something, which is the most important thing here, which is reading the DICOM file. So DICOM file equal to PyDICOM dot DCM read, and then we give the DCM file. Okay, so we need first to read the DICOM file, and then we extract the information or change the information. So here we have the DICOM file, okay, and then we have the .image type. Here I switched it, so here it should not be there. Let me put it here, and sorry, well, I don't know what I am doing, but here, and then the image, yeah, DICOM file dot image type equal to image type. So if we specify the image type, then we need to change it. But here I am forgetting the if condition. So if image type, then we change it. So if the user specifies the image type, then we change it. So DICOM file dot image type equal the image type that we given in the parameter. So when we call the function, we give it here. And the same thing can happen for the others. So if we want to change like the image, the patient name, patient sex, study ID, slice thickness, patient position, study instance, all these things can be changed using the same function and the same way. So just to gain time, I cannot write everything here inside the video, so it will take like an hour or something writing all the conditions. So I will just copy and paste them here. Let me just delete this, and you can see the exact thing here. DICOM file data path. So DCM file, it should be here. Okay, so now what is happening? We are in the parameters of the function. I am presenting all the tags that can be changed in a file. So you can see that we have all these here, all these things that you can use, and this is how it happens. So for each tag, I am giving a condition. So if the user wants to change this, then it will be changed. If he wants to change this, or if you want to change everything, so everything can be given in the parameters. And of course, the function will be called. It will do all these changes, and it will return a new DICOM file that is changed, like, which means that it has the new tags that we specified in the parameters. And of course, if you want to save it, then you need to call the function. So let me just run this. So change tags. So let's say, for example, new DICOM tags, for example, let's say, no, with tags, for example, and here it is the function that we will use, change tags, and here we give the path to one slice, which is, for example, data slash slice, this one. Okay, and then if I want to change one of the tags that are available, so let's say image type, okay, and it should be string. So let me give it, like, I don't know, RGB. I don't know what does it mean here, but I am just giving it a parameter just to be different than the by default one. Okay, and now since you have a new DICOM file, you changed only this. If you want to change the others, of course, you can add everything or all the tags that are available here. And now when you complete this, you just need to save it. So new DICOM file tags with tags, then save as, and you give the path, for example, data slash edited slice, something like this. Okay, so let me just run it, and you will get new edited slice here. If I read it and see the image type, you see that it is RGB. We can do so if you want to test. So let's say uploaded DICOM changes or something, or let's say that's uploaded DICOM, just like that. Keep it simple. So PyDICOM that DCM read, and then here we give the path to the edited slice. Okay, now let's print like uploaded DICOM that image type. Okay, let's run it, and now you see that it is RGB, which is the same thing that we gave. In reality, at the beginning it was image type, it was something like this, original, primary, actual, it was something totally different. So we gave it the variable RGB here when we called the function, and now you see that when we loaded it again after saving, and when we are printing the image type, it is like this. So this was how to change this this kind of things, which is all the tags, because I know that some of you sometimes wants to change some of this information, but like if you use another software, it may be slow, like the process will be slow to upload these things. But if you want to run a Python script that does everything, you can use directly this function. It's already ready for that. You can just call it and give it the information that you want to change. So of course, as always, if you have any questions about this, you can just keep it in the comments, or you can create a new discussion in the community, and I will try to answer you as soon as possible. See you. Now, after that, we did the changing in the tags. So there is something else that we can change as well, which is the information of the image. So there are the tags, which are the information about the file and the information about the patient. But the most important thing, which is the image, which is or the pixel array that we want to change. But here the thing is a little bit different when changing it. So let me create a new markdown here. So changing, for example, the voxel or the pixel array. Let's say values, for example. Okay, so when we want to change this, it is a little bit tricky, because let's say that, for example, we have this file, so that we just gain time. We have the uploaded DICOM file. If I put pixel array, okay, you see that the values are from minus 900, and it is not from, but you see that the values are, there is values like minus 998. There are like the same values that we had for the other for the same DICOM that we had. Like this is the same DICOM, meaning that the same values. Okay, but if I want to change this, so here there is something. We cannot do the same thing that we were doing for these tags. So I cannot just put pixel data, for example, let's say equal to, if I just want to give the same thing. So if I put it like this, so if I run it, it will give you an error, because this uploaded DICOM, that's pixel array. So this function does not accept to give another, so like it is not for inputs, it is for output only. So I cannot give it a value to change it in the DICOM file. But instead, if I want to change it, there is another variable that I can call, which is the pixel data, which is this one here. So if I call this pixel data, then I can change this DICOM. So if I want to do that, I can just call but before that, we need to see the type of this pixel data variable, so that we understand what we want to do. So here, okay, let me delete these until here, and for example, okay, for example, let me print the type of this pixel data. That's pixel data. Okay, so now you see that the type is byte. It is not a NumPy array as we had before. So when you do the DICOM file .pixel array, it will give you a NumPy array. But when you want to input a new file, so when you want to change this pixel array, you need to give a byte and not a NumPy array. Okay, so remember that with me. So if you want to give it, now before doing that, let's create a new DICOM array, DICOM array that will take the place of this file here. Okay, so let me give you something like okay, new array, for example, and let's create new np.zeros, which is an array or containing only values of zeros. Okay, and now we need to specify the dimensions. So for example, let's give the same thing, which is 512 by 512. We can give something else, it works, but I'm just trying to keep the same dimensions. So 512 and 512. But as you see here, this is another type. This is a NumPy array, but we want a byte array. So to do that, we just need to click here dot and 2 bytes. We convert it into bytes. So here we will have an array, but it is converted into bytes, because if we don't do that, we cannot give it to the pixel data here. We need to change it into 2 bytes so that we can give it to this pixel data. Okay, so now I have created this new array. If I want to give it to the pixel data, there are 2 ways to do that. I can either do it from the beginning, or we can directly use the function that we created. And you see here, for example, we have the function and we can use it for all the things. And you see inside this function, we can give the pixel data. So let's do that, don't we? Okay, so let me take, let's create another variable just for the course. So new DICOM pixel data, for example. Okay, now let's do the same thing. Like we have the change tags, okay, and then we give the path to this slice, so slice, and then we give the tag that we want to change, so which is here pixel data. Okay, now what we need to give, which is new array. Okay, now we change the pixel data into new array. Let me just run it. Now everything is good. There is no error because this this variable, which is pixel data, accepts to give a new array here. Now, if we want to check, you see that it is the same slice. Here it is giving the values -998 and all these things. Now let me just do the same thing. So if I do new pixel, new DICOM pixel data, if I print the pixel array, let's see what it gives. You see now it is giving zeros, only zeros, because we created a new array here, zeros, and we assign it to the pixel data here. So we change the value. We cannot change it using the pixel array. We cannot put new DICOM file .pixel array equal into the new array, which is the zeros, but we can use it in the pixel data. If you use pixel data and you give it a new array, then it will change the image inside the DICOM file. So this was how to do this changing. And you see we are using always the same function, which is change tag. So this was how to change the value. If you have any questions, just let me know, and see you in next videos. Now I can discuss something that may be interesting for you, which is if you want to convert your DICOM file into PNG or JPEG image. So let's say that you don't need all the informations inside the DICOM file and you need only the image, then you can convert it into something that can be read everywhere, which is PNG, JPEG, or TIFF, or anything like that. Okay, so let's create a new markdown here. And let's say converts DICOM into PNG slash JPEG, for example. Okay, you will see that it will be easier since we have already some functions that we have built before. For example, this function and the other one. Okay, we can use one of them, and this will help you to create the PNG or JPEG image. Okay, so the first thing that we need to do is to read the DICOM file to do some pre-process or post-process and return the unsigned integer 8-byte image. So I think this sounds familiar since we have already done that when we were doing the visualization. So we can use the same thing for the savings. Okay, now let me just show you to read the image. So for example, EMG for image equal to normalize and visualization 1 or 2. So let me choose this second one, for example, because it is more flexible and gives more clear visibility. So for example, we use this, and after that we need to give the path to a DICOM slice. So let's say data slash the slice that's DCM. Okay, so this is the input slice. Then let me just specify the max v equal to 100 and min v equal to minus 200. Okay, so now if I do that, now I have the image. If I want to show it, we can just do the visualization. Otherwise, if I want to save it, then I need to leave it like that and use the part of below to convert this, because here it is an array. It is always an array since I am not doing the visualization. So if I want to save it or do anything with it, I need to convert it into image. So let me just make it clearer. I will put it here, array, here, yeah, array, and now I will convert it into image. So image equal equal image that's from array. Okay, and here I need to give the array like this. I don't know why I'm writing a lot of R's. So here we have the new image, but now it is only an image, but it is only in our code. We didn't use it for the saving. So if I want to save it, I need to click on say image dot save, and here you give the path to the output. So for example, let me put it into data slice dot, for example, PNG. Okay, if you want to save it as JPEG, you need to put slice.jpeg and it will be saved as JPEG. So now let me just test it. It will be like this. Okay. So here is the image. You can see that we saved the image inside the data folder. So here is the image. It is like the same thing that we had, because we are using the maximum value 200 and minimum value minus 200. I think here I forgot to put the show into false. Okay, so that I don't want to do the visualization each time to do the conversion. And you see here we have done this without any problem. And yeah, this is how to convert into PNG or JPEG or anything you want. In next videos I will show you how you can do that with multiple slices. So if you have a lot of slices, you can use the same part but with a lot of slices. So see you in next video. So after that we did the conversion from DICOM into PNG or JPEG. Now let me show you how you can do the same thing but for a group of DICOMs, which means if you have a directory having a lot of DICOM files, which is always the case, so you cannot have only one slice, you should have like multiple slices. So when you have this, so you will have one directory like this, for example, containing all the DICOMs for one specific patient. Okay, so this is one case from Corona Scans. I found it in Kaggle, just for the testing, and for the slice that we were using in our previous videos, it was taken from this scan. Okay, so now it will be the same thing that we are doing here, but it will be applied in a group of DICOM. That's what will happen. So to do so, there are two ways to do it. We can either like directly create everything here as a script, small script in a cell, or we can create a function using this approach, and then we apply the same thing for all the directory, but with calling only this function instead of creating again and again everything. So let me just show you how it looks. So the first thing that we need to do is to convert this three lines into one function that we can call after that. Okay. So let me just write it here. So def, for example, let's say DICOM to PNG, something like this. So the first parameter that it should take, this function, will be it should take almost all these parameters, especially if we want to call this function for the conversion. Otherwise, if we want to use the other function, then we don't need these. Okay, but since we saw that this function help us to normalize the image and take the exact contrast that we need, and like we will have a clear visualization. So for this reason, we will use this function. Okay, so here the first thing that we need to take is DCM file. So it should take the path to the DICOM file, okay, which is the same parameter as this function. The second thing, let's call it the same thing, like max v and min v, something like this, okay? And then, okay, let's go to the function. So what we are going to do is this. We'll take this line at the beginning. Let's take this and change this part here into DCM file, okay? Because it is the same here, I'm calling it here, and the same thing here for the max v and for the min v. Okay, and the show, we will leave it as false because we don't need to visualize every slice that we will convert. Okay, so here we are creating the array. Then we should convert it into image. So I will take this and put it here, and then after converting it into image, we need to save it. So I will take this here, but you see here it is a normalized, it is like a normal one path that I am giving here, but in reality it should not be like this. I would prefer saving it in a slice, in the name of the slice, for example. So if you have a group of slices, something like this, so each image will have the same name, but that's PNG, for example, so that you will not lose the other, because if you give the same name of the slice for all of them, so you will always take the image and replace, so you will replace this one by this one, the second converted image by the first by the second, and the third by the second, everything like this, because you will have always the same name of the file. So we should always give different names. I know that this is basic, but I just want to say it. So you need to give different paths or different names of the files if they are at the same path in when you save them. So we need something else here, which is more important than this, which is the PNG files, something like this, okay, or PNG path. Okay, because you will need the path where you want to save the images plus the name. So the name will extract it directly from the slice, but the path here we need to give it in the parameters. So let's do that. Now the thing that we are gonna do is to extract the name from this path. So I can do it just here. Let's say case or slice name. Okay, then equal to. Then here, since we have already the DCM file, which is the path to the whole slice, so we can do os dot path dot base name, and then I think I forgot to run the cell, or I didn't include it. Maybe. Let me see. Yeah, I forgot to include the OS to import the OS. Okay. Now we should not have that warning error. Yeah. So now we have the base name. So this function, it will return. So if, for example, you have a path, something like this. So let's say png slash path slash something dot png, for example. So if you give this path to this function, which is base name, it will return directly the last element of the path, which is this one. Okay, that's what this function will return. So for us, it will be like, for example, data slash case corona case, for example, then slash case corona scan, sorry, slash the name of the image. So for example, the first one, it will be image 301.dcm. So this function, it will return only image 001 DCM. This is the return of this function here. So we can do that, but since we need only the name, we don't need the extension. So we need to take or to split. There are two ways we can split, but I find that this is not, this is like we are taking another line to do the split and all these things, but it's a waste of time. So we can just do, you take everything minus 4. Why I am taking everything minus 4? Because I have this, so I will take everything here minus the last 4 elements. So the last 4 elements are, for here, it is PNG and the point, and for the other case, it will be .dcm. So it will be point DCM. So what we are going to do, so we are just extracting the name from the last part here. This is the last part, so we are extracting the name and deleting this. So everything minus 4, okay? Now, after doing this, what we can do, we just need to give the name in the saving part plus the path where we want to save, which is the paths, the PNG path, okay? So let me delete this part here. I am putting F, which is like for the F string. It helps you if you want to include a variable inside the F string. So for example, I am writing here Amin, for example, and I want to include the variable name. I can just do add these brackets, and here I can put the name that I want, which is slice name, for example. So I can include the I can include a variable inside, and this variable should be a string, of course. So I can include the string here, the variable inside the string, because you see here it is inside the quotation marks. So I can add it here. Okay, this is the help of this F. If I delete it, for example, this will give me error. I cannot use this. Okay, so let's come back here. And why I am doing this, there are a lot of ways to do this part, but I just like this one. It looks a little bit fancy, but yeah, it is one of the 3 or 4 ways to do the same thing, to create the paths. So here, as I said, we need the first part, which is the DICOM, the PNG saving path that we gave in the parameters, which is PNG path, and then slash, and then we add the name of the name of the case, which is slice name, okay, and then we give the extension, which is .png, or if you want, you can give it .jpeg, okay. So this is how it happens. So this part here will create the path of the output, so the png path slash the slice name .png, okay. So this is the function that we are going to need. So let me just run this function. If we want to test it, I can do DICOM DICOM to PNG, and then I give the DICOM file. So for example, let's say data slash slice DCM, okay. And yeah, I think this is how it can be. Now let me give the path to the output. So the path to the output, let's say for example data slash test, something like this, okay. Let's leave it like this. But since this this folder does not exist, so let me just create it. Sorry, data, and create test, just to test this function, okay. So now I am giving it like this. Why it is giving error? I forgot I should put a comma here. So here, this is the path to the image, and this is to the input, and this is for the output, okay. So let me just run it. There is error. Yeah, sorry, I forgot to add something here in the function. These should be by default none. So if I don't want to adjust the contrast, it should be none. Now I can run it. Always there's another problem. Sorry, maybe since I started the project again, I didn't rerun the function. So let me run it again. Okay. Because you see here, since we are in Jupyter Notebook, so if, for example, you close your project and you start again and you don't run like the previous cells again, so the program will not recognize them. You need to run them again, okay? So yeah. Okay, now we have the conversion has been done correctly, I hope. So now here is the image, you see. This is by default. Now if I want to do adjustments, I can just add the, let's say max v equal to 200 and min v equal to minus 200, okay? So let me run it. Now, if I go to the image, you see that it is the same thing that we created before inside this test folder. Okay, so why I'm doing this? Because I will need this function to do the conversion for a whole directory. So to do so, let's just call, before that, I create a markdown. So here, convert a group of DICOMs into PNG, for example. So here, to do so, let's just, at the beginning, we need to define the path or the list of paths that contains all the DICOM files. So let's say DICOM files path, for example, and it's equal. The first, the library that we'll use called global. So this function, this library global will help you to, it has a function like the library called global, and it has a function called global. So this function global will help you to, like, if you give it a path, it will return all the, so for example, if you have 3 elements, so it will return a list containing the paths for all the elements that are inside this globe function, okay? So if you are doing this from the beginning, I think you should not have it in your environment, so you can just install it. For me, I have it, but you need to do pip install globe, but globe, it will not work, it won't be recognized, so you need to add 2. I don't know why, but when you want to install it, you need to like do pip install globe 2. You don't need to put only globe, because when you are using it, when you import it in your code, you just import globe, but here when you install it, you need to add globe 2, something like this, okay? So I have it already. Now let's go to the code. What we are going to do, like the first thing, as I said, we need to import it. I will add it just here, for example, import or from globe import globe. Okay, Let's run it. Okay, now here what we need to do is to give the to call the globe. This is the first thing, and then we need to give the path where there is all the dicoms, which is this one here. So I have data slash case corona scan. Okay, and then you need to add something if you want to return everything that is inside of, if you need to return all the paths that are inside this directory, for example, you need to add this. The star means everything, but if for us, for me, I am sure that this folder contains only DICOM, but it is not always the case. Sometimes if you have scans, like a directory having scans, it may contain other txt files or something like that. So this will cause a problem when you call this function. You give it a txt file and you ask it to convert it into PNG. It will not work. So to be more specified in this, you can add everything.dcm. What does it mean? All the files that are in this folder with the extension DCM, you will take them. Otherwise, you cannot take them. So this is how it happened. So let me run this. Now, if I print DICOM files, but okay. So if I run this, you see that I have a list containing all the DICOMs until EMG 0301.dcm. Okay, if I don't add this, it will be the same, but if you are not sure if all your folders may contain something else, then you need to add .dcm so that you don't get confused. Okay, let me delete this cell. Now everything is here, return in DICOM files path. Let's go to the next step, which is converting all these DICOM files into PNGs. So to do so, the first thing that we need to do is to create a folder where we want to add, or where we want to put the PNG file that we will create. So let's say PNG folder, for example. Okay. Now here we need to do a for loop that will pass by all the files, which are all the paths that are in this list, and convert them into PNG. So we have for file or DICOM file in, then here we have DICOM files, but okay, for all the DICOM, for one DICOM file inside the list of DICOM paths, let's do the thing which is calling the function, because here was where I told you that if we don't have this function, we need to do everything here, we need to like put it there. But now since everything is set, we just need to call the function and give it the parameters and it will do everything. Okay, so now let's call it. Here we have DICOM to PNG, and the first path should be the path to DICOM, which is DICOM file. The second parameter should be the path to the output, to the PNG. So for us, it is data slash PNG folder. And then the next thing, which are the parameters, of the other function. So if you want to change the contrast, then you need to give something here. Let's use the same parameters that we were using. So 200 minus 200. Okay, so let's run it. You see that the function, the for loop is being run. So now it is completed. If I go to the PNG folder, you see that we have all the slices here. Everything is here. Okay, let me go far away. Here you see these are the files that we converted from PNG into from DICOM into PNG. So this is how you do the conversion for a group of DICOMs or for the whole scan. So if you have any questions about this, please let me know. You can put it in the comments, or you can create like a discussion in the community. See you. Now, after that, we have done the conversion of group of DICOMs into group of PNGs or JPEGs. If you want, you can just change it in the function. Now what we can do is to convert a group of DICOMs into one NIfTI file. So the NIfTI files are a group, like it contains the information about the whole scan. So instead of having multiple files, you can have only one file representing the 3D representation of the scan, of it can be segmentation or anything like that. So this is like a simplified definition about this. If you want to know more, I will attach a blog post with this lecture so that you can go to it and read more about this conversion, or about what is the NIfTI file, what is the difference between NIfTI and PNG, NIfTI and DICOM files, and all these things. Okay, so to do the conversion, we are going to need only to one line of code. So let me just create a markdown here. Converts a group of DICOM files into NIfTI, for example. Okay, now to do that, the first thing that we are going to need is to have the group of DICOMs, which is the directory having DICOMs, which is the same one here that we had before. And then we need the path where we want to save the NIfTI file. So to do so, but for this reason, for this part, we are going to need the library DICOM to NIfTI that we installed at the beginning. So we need to import it first. So import DICOM to NIfTI. Okay, let's run this cell to do the importation. Now it is imported. Now let's define at the beginning the path to the group of DICOMs that we have. So path DICOM folder equal to data. Then here we have case corona scan. This is the path to all the DICOMs that we have. Now what we can do is just to call a function, which is here we have DICOM to NIfTI, that here DICOM series to NIfTI. So this function DICOM series to NIfTI takes two parameters. The first one is the path to the folder where there are DICOMs, and the second parameter will be the path and the name plus the extension of the NIfTI file. So here, as I said, the first thing is path DICOM folder, and the second thing is the path where you want to save the DICOM folder, the NIfTI folder that you will convert. So here we have data, then you give the name. So for example, let's say case corona, let's give the same thing, corona scan. Okay, and then you need to give the extension. So the extension of NIfTI file, which is NII. But if you want to create a compressed file, then you need to add .gz. The compressed files are the most common files because they are like 100 times smaller than not compressed files, which is if you leave it just NII without gz, and it is easy to use, like very fast to load them in your code and all these things, and it will not take space in your disk. So preferably you need always to add .gz so that it will create a NIfTI compressed files or compressed NIfTI files, something like this. Okay, so let's run this cell and you see that it is running. Let's wait for a few seconds and the file will be created. Okay, so now the file has been created. If I go to data, I think, yeah, this is the file. So if we want to test it, let's just create, or let's open ITK Snap or 3D Slicer or anything you want. Here, desktop. Let's go to data, and here, let's go to this. Okay, this one, the case that we created. Let's open it here. And you see that it is the same case that we had in the DICOM files, but now it is in NIfTI. And you see that one file containing all the slices. We can also play with the adjustment, like -200 and 200. Okay. And you see it is the same thing, same visualization, same contrast, and everything is the same. So this was how to convert the group of DICOMs into NIfTIs. If you have any questions about this, please leave them in the comment. Now, after that, we did some conversions with the DICOM files, like to GP, to JPEG, to PNG, into NIfTI. I wanted to present something that may be interesting for some of you, maybe for not all of you, but it may be interesting, which is converting the DICOM slices, all of them, into one video, directly MP4 video that you can run. I think some of the doctors or some of the clients that you may face may need something like this. So if they have a lot of DICOM files that can be opened only on specific types of software, and maybe they want to convert all these things or all these DICOMs into one MP4 video that they can share with their patients, or maybe they can use it for fast visualization, then here in this video I will show you how to do this conversion. So let me just, as always, I create a markdown, convert DICOM to MP4, okay? And this will be the last video for the course. After that, it will be only the videos about the project. But for now, this is the last video for the explanations. And yeah, I hope that this course was helpful or useful for you. And as always, I say, if you have any questions about any of these lectures, please leave them at the comments or in the discussions in the community part, and then I will try to answer you as soon as possible. Even if you have questions for the DICOM files that I didn't talk about in this course, you can always leave them. And if it is possible, I can add more lectures about them and you will access them with the course, okay? So to do this conversion, there are two things that we are going to need, which is the first thing is the path to the DICOM folder. So we have it already. Here we have a folder containing all the DICOMs, but for now it is always only the path. We need to convert it into a list of paths, which is the same thing that we used here. So here we converted, I think, group. Yeah, here, this is the DICOM path, DICOM files path. Here we returned a globe, which is a list containing all the paths to the DICOM folder. So that's what DICOM files, sorry. So that's what we are going to need, DICOM files path. So yeah, we can recreate it again, or we can directly use this one. So to be easy for you to follow with me in this lecture, I will just rerun it again here, so that you see it. So here we have the DICOM files path. The second thing that we are going to need is the frame size. So when you are going to create a video, you need two parameters, which is the frame size and the how many frames per second you want to have in your video. Sorry. So for the frame per second, let's say frame per second. Let me choose, for example, 15, because I tried multiple frame per second values, and sometimes the video is very slow, sometimes it's very fast. I found that 15 is the best for me, but if every one of you can change this value, so that will be easier for him to follow with me. So you can choose the value that suits for you, and maybe you need the video more slow, some of you need it more fast, so you can play with this value. I will show you the video that we will create using 15 frame per second, but you can see with the others. So here we have 15 for the frame per second, and we need the frame size. So the frame size, we can either, it should be a, it is a tuple. Like we can either give the values directly here, 512 by 512, but here, because we know that the frames that we have the values 512 by 512, but this is not a general thing. It will not work for all the DICOMs or all the scans. So if you want something more general, what you can do is to take one frame of your dataset and return its shape, which is the same thing. It will return a tuple containing the weight and the height of the frame. So to do so, let's just take one file from these and read it, and then we can return the shape. So let's try something, because I want to put everything on one line. So let's try it. If it won't work, then we can do it in multiple lines. So we have the PyDICOM dot DCM read, okay, and then we give the path to DICOM. So here we have DICOM files path. This variable contains a list of DICOM files. So for us, we need just to take one of them. So let's take the first path, which is the first slice. So 0 here, and then we do something like the next thing that we need to do is to Okay, sorry, we read it. Then we need to extract the pixel array, which is the image. So we have pixel array. And then when we are doing this, we are returning the pixel array from the DICOM file that we get. And then we want the shape, which is this one. Okay, so let's run this frame, this cell. And if I print the frame size, you will see that it is 512 by 512. So here we are directly giving an automation with this frame size. So if you change the path to your DICOMs here into another scan or another patient, and it may contain or it may have different frame size, or like it is the image size, the width and the height, then it will be changed directly here. Another thing that I need to specify, which is the order of the DICOM. So this function, it may not return a list containing the files in the exact order. So when you create a video, you will not get a follow-up, like you will not get the first slice, second slice, third slice, etc. You may get the first slice and then the 15th slice after, or something like that. So we need to order this, and to order these things, we need to do sorted. So this function sorted will sort everything inside the list. So we'll have the exact index of the files here. So this will be the first, second, third, etc. So when you create the video, you will see that the image or the frames are being changed like correctly, like frame by frame, instead of having the frame 1 and then we have frame 15 or something like this. Okay. So here I just put sorted. Now everything is set, and then we are calculating the frame size. Then the next thing that we need to do is to create the out, which is the video writer. So we need to create video writer. It is from CV2, so it is in OpenCV that we will use. So out, for example, which is the out, it is a variable that will contain the video writer when we want, where we want to write the video. So CV2. It is not recognized. Maybe I forgot to add it. So let's include it here. Code import CV2. Okay. Now it should be recognized. So CV2 dot then video writer. And this video writer takes for now, it will take only four parameters. You can give more, but for us, we need only 4. The first parameter is the path to the output video. So let's put it in data, path plus name, of course. So data, then let's say corona scan.mp4. Okay, so this is the path to the output video. And then the next thing will be the type of videos that we want to create. It is not something that we need to know all the details about it, but it is like cv2.video writer sort. Okay, and then here the type is star, then divx. Okay, so this is not something that we need to know, because it is out of medical imaging and all these things. It is only of how to write a video in OpenCV. So we don't need to know all the details about this. It is only about the type of video that we want to create. Then the next thing should be the frame per second that we defined before, and the last thing should be the frame size. Okay, so these are the parameters that we need to add for now. So this is the out, which is the variable that will take the video writer, where we want to write the video. So let's run it here. Now what we need to do is to write a for loop that will take all the frames or all the DICOM files that we have. It will convert it into image, and then it will add it to the writer. So to do that, let's just put for file name, for example, in DICOM. Here, where is the DICOM file paths. Okay, and then let's go to the first thing that we need to do is to create the image from the DICOM file. So let's use the same image that we had, the same function that we have, normalize, visualize DICOM. I will use the second one so that I can adjust the values of the contrast. So here we have file name, which is a DICOM file, and then we have the max v and the min v. So max v equal 200 and min v equal minus 200. So now we are defining the image. What we need to do after that, because it is true that we are saying image, but it is always a numpy unsigned integer 8 bytes. So we need to convert it into a CV2 image. So CV2 image equal to CV2 dot CTV CVT color, and then here we have the image, and then we convert the image from RGB into BGR. So here we have CV2 color RGB to GBR. Okay, so this is how to create the image for special, like if you have any type of images you want to create, you have to convert it into CV2 image, which is OpenCV image, then we use this line. And after having the image ready to be written, then we just need to write out that write, and then here we give the image, which is CV2 image. Okay, and after completing everything, let's just release the writer. So release. Okay, now let's run the cell. Okay, yeah, I think I forget to do something. I see. I closed everything here, even the even the VS Code. The thing that I forgot to add, which is the visualization here, it should go to false, because I don't want to visualize everything. I don't know if it will work for now since we close everything, so we need to run the functions and the includes and all these things. Sorry about this. I will rerun this line. Now it is recognized, show image, this one as well. And I think, yeah, we don't need something else. Yeah, globe, we need it. This one we don't. CV2, then this, and this. Now it is converting the images into one video. Now it is created. If I go here, I cannot see it in VS Code. Then let's go to the folder directly. So let's run this. And here is the video that we created. You see that like we are going like slice by slice, and we are seeing all the evolution in this scan, which is for one patient. So you see the speed for me, it looks good, because if I change this frame per second variable, so if I put it like 30 for something like that, if I put it 30, it will be very slow. If I decrease it, it will be very fast. So you can play with this variable, which is the frame per second. So if you see that this value is good, then you can leave it like this. If you want something better than this, then you can change it. So this was how to convert the DICOM directory into like video MP4 that you can play or share or something like that. In the next videos or next section, we can talk about the course project that we will see, and I will explain to you how it works. And if you want to customize your things, you can find everything in the next section. See you. Welcome to this section, which is the course project, where I will show you if you want to put all the functions that we saw in this project, in this course, sorry, and you want to put everything together in one application that can be used in your daily life if you are a radiologist or something. So let me just give you an explanation how it works. So for example, this is a Python application that I built using tkinter. So you can see that it's very easy for the user interface. It's very easy. If you want to do something, I will show you what we can do with this application, and you will see that all the operations that are here has been done in details in the codes. Okay, so for example, we can click here to open a directory containing one DICOM file or multiple DICOMs. So here I just open them. When you see here this folder contain DICOMs, meaning that exactly the folder that we chosen contain DICOMs. If it not, it will put to here that it will write here that the folder that we choose doesn't contain any DICOMs. So you need to change the folder or check if your DICOM files are there or not, or something like this. So here we have uploaded the DICOM files, but you see this is like by default image, so we didn't visualize anything. So to show what we have uploaded, we just need to click on visualize, and when you click on visualize, you will see here, and even these sliders were disabled at the beginning since you didn't visualize any image. So now when you do the visualization, the sliders will be enabled, so that if you want to go to the next slices, you can do that. And these here are for changing the contrast. So you remember we had the house field min and house field max. So these here, max and min, will control the house field min and house field max. So this is how it happens. And you see, we saw how to, for example, here we are just changing the slices. So if you remember when we had a list containing the paths of the DICOM files, so here we are just changing the index of the list. So for example, when I am here, so I am taking the image 0 from the directory, which is the first part of the list. That's the function globe returned. If I go here, which is the first one, second, etc., until the last image. And here, as I told you, here we control the house field max and house field min. So here, if I decrease this one here, which is the max, and this one is the min, so I can go, for example, to the values that we were always using, something like minus 200, okay, and plus 200, okay, something like this. Okay, let's leave it like this, for example. And you see here we have the image with the values. I can go to until the 200, why not? We need to be more sensitive. I am just clicking here, and you see that it is being changed here. So everything here in this application can be customized because I built it from zero. And you see, and I will, for this section, I will work with you for all the code, and I will show you how everything is set. So if you want to customize it, you will see where you need to touch. So you see, for example, for this slice, we choose this 200 for the max and minus 200 for the min. And you see, it is the same thing that we had before. So now if I want to scroll to the other slices, if I just scroll without touching anything else, you see that the contrast has been reset into the first values, which are by default values, because the code here is written like, if I don't apply here, if I don't apply this the contrast that I choose for all the slices, then whenever I scroll to the next slice, everything will be reset by default here. And here the maximum and the minimum values are here with the exact values in this slice. So for example, the maximum voxel value in this slice is 1697, and the minimum is minus 970. Okay, so now let me just show you how it works. I can go here whenever I want, but if I want to apply the same value, so for example, let me go to the 200, something like this. Okay, let's leave it here. And for the minimum, let's put it to the minus 200. Okay. And if I want to apply the same values of contrast for all the slices, then I need to click on apply. So when I click apply and I change the slices, you see that it has been applied for all the slices. And if I want to change them, I need to click on change, and then I do the changing. So this is how to do the visualization. If I want to show the patient's information, then I click on show info, and it will give you this window containing all the information here. And you can visualize them and see, for example, if you want information about your patient, about the study ID, everything can be found here. Okay. And then if you want, for example, to anonymize your DICOMs, then you just need to click on anonymize, and then you need to choose the directory where you want to put your new anonymized DICOMs or new anonymized files. And then you click on select the folder, and it will create the new anonymized DICOMs directly. And if you want to save your images as a PNG, then you click on save PNG, and then you choose the directory where you want to put your PNG files, and then everything will be done. And the same thing for the MP4. If you want to convert your slices into an MP4 file, then you can MP4 video, exactly. Then you just need to click on here and choose the for example, the folder, if I want to save it here, and then you click on select folder, and it will create a new MP4 video with the same contrast that you see here. And the same thing for the save PNG. If you click on the save PNG, it will take the exact contrast that you are applying on the slice or the other slices, for example, and will be used to save the PNG or JPEG images. So this was how the application works, like in general. In the next videos, I will show you part by part, but we are not going to code it from zero, but I will just show you where the functions are placed. So for the first part of this section, I will discuss how the skeleton of this application has been built, which is the front end of the application, which is this one here. Something that you need to put in mind, which is to build this application, you can use tkinter, which is the base library, and it is already installed with Python, or you can use the TTK bootstrap, which is a customized tkinter application. It works the same thing. So when we call any function, because I don't know if you are familiar with tkinter, but it is the same thing as tkinter library, but it has some modern things like modern buttons, modern themes, modern text, modern labels, and all these things. So this is why I am using TTK bootstrap, but unfortunately, TTK Bootstrap is not installed by default with Python, so you need to install it directly using pip install. So you can go to the terminal, and here, you go to the terminal, and you just need to type pip install TTK Bootstrap. Okay, and then you see that it has been installed directly. So this is how to install the TTK Bootstrap, and after that you can use it directly here. Okay, so now after installing, for example, TTK Bootstrap, the first thing that you can do is to initialize the application, which is ttk.window. So if you use that ttk.window, it will just initialize a small window, which means that TTK Bootstrap is working on this environment. And then here there is the application.geometry, which is used to control the width and the height. So 900 is the width, and the second part is 1300, which is for controlling the height of the application. So here we have the width by the height. So you can, if you want to play with these dimensions, just you can change these values here. And then for the theme, if you go to the documentation, you will find all the available themes. I think there are 7 or 9 different themes. So for me, I am using the superhero theme, which looks like blue, which was like something closer to the medical imaging thing. So if you want to use something else, if you want to change the color, then you can find this in the documentation. And then, for example, for the title here, this DICOM Simplified, it is not this one, but it is the title of the application, which is this part here. Because if you see, we have the same thing, which is DICOM Simplified, this and DICOM Simplified. But this one is a label, which we will come to it later. And the second one, which is the title, which is this part here, the title of the application. Okay. And then we have the, this one we don't need to talk about it now, but it is controlling the width and the height of the viewer, which is this one. So this is the width and the height of the viewer. So since it is a squared viewer, then I am using the dimension. So for the width and the height is 600 for both of them. Okay. And then, this part's, so this part here, we are uploading the default image, which is this one. So this image, I am just putting it by default so that we see that this part is allocated for the viewer part. So I am just using this image, and everything will be shared with you. Don't worry about it. So when you get the project, you will get everything with it, even this image and all these things. I will explain how to use the code at the end of this section. Okay. So after reading the image, I am just creating a label and putting the image on it, okay? And then the next step, which is this DICOM Simplified title. So as I told you, there is DICOM Simplified, this one, which is the title of the application. And there is DICOM Simplified here, which is a label inside the application, which is this part here. Okay, and now let's go scroll, because here, these are the functions that I am using. but here we can talk also about these parts. So for each part, for example, here we have different buttons. So the buttons, I am putting them on a frame, and then I have the viewer in a frame, and then I have these sliders in a frame and the buttons in a frame. Why I am using these frames? Because actually I found that it helps you when you want to organize the application. So if you don't use the frames, then you need to place each element in the application. Like you need always to know the exact X and exact Y, or if you use the grade function to place the things in the application, it won't be precise and you cannot organize your things. So for me, I take like each section as a frame, and then I pack them. So when it is organized, the frame, and I just need to place the frame, and frame by frame, it will be easier than placing elements by elements as you see here. So if you want to change anything about these applications, you need to go, if you want to delete all these parts, then you can directly delete the frame. Otherwise, if you want just to change the buttons or rename them or something like that, then you can come here. Here we have the, and as you can see here, there is buttons. So there is the open button, which is this one. If you want to change anything about it, if you want to rename it, you can rename it in text. If you want to change the width of the button, then you can change it here. If you want to change the functions that are being called by this function, by this button, then you can change them in the command parameter and something like that. And if we go, for example, to visualize, to show, if I want to visualize something here, then I need to click on this button, which is visualize button, and this button is also customized 100%. So if you want, you can change you can rename it, change the like the style of this button, the width, and everything can be changed. The same thing for the others: show info button, anonymize button, PNG, MP4. All these buttons can be changed here. Okay, and then we have the sliders, which are these. So I am creating sliders for each slider I'm creating the label. So here I have a small label named slice. So here, just to show you that this slider is for slice, and this slider is for max, and the other one for min. And always here there is the label for the title, which is slice, and then we have the scale, which is this one, and the same thing for the others. And here, for example, we have the value, which is this one here. So if for the value here, it is being calculated and printed, which is showed, if you want to say, as a label, which is this part here. So in this part, I am showing the value of the slider. So whenever I changed it, it will be updated here. Okay. And the same thing for all the sliders. For each slider, there are 3 parameters: the label for the title, the slider, and the label for the value, which is this one here. Okay. Now, yeah, this was for these, and for these 2 buttons, which are now they are disabled because I didn't upload anything in this viewer. So whenever I upload or open a directory and click on visualize, these sliders will be enabled, and the same thing for the apply button. Okay, and if I click on apply and I want to do some changes, then I click on change and everything will be changed. Okay, so this was how to show all this part, like where are the buttons if you want to change them, where is the labels, which are these sliders, these buttons, everything can be changed in the parts where I shown you here. In the next videos, I can show you where we are calling the functions that we created before, and you will see that everything is the same, only the way of how we are calling them is different. Now let's speak about the visualization part. So whenever someone click on visualize here, which is the button for visualization, of course, after opening the DICOM directory. So whenever the user clicks on visualize, what will happen in the application? So in the backend here, what it happens, this is the function visualize that will be used when the user clicks on the visualize button. So this is the function, the first one that will be called, and this function will depend to other functions, but this is the main one. So what happened? The first thing that we need to do is to check if DICOM files, if DICOM files, what does it mean? If the because this DICOM files is here, which is whenever the user clicks on open DICOM. So if he chooses a folder that has or that contains the images, or it contains the DCM files, which is this one. So DICOM file, it is the globe of all the files inside the folder containing DCM folders. So if the user does not choose any folder or if the user chooses a directory that doesn't contain DCM files, then we can do nothing, since there is no DCM files found in the folder. So we need to check that before. So when we check that the directory contains DICOMs, then we can go to the other places. Otherwise, it cannot be used, and it will show you that you need to choose the DICOM directory first. So now, after checking this part, we need to initialize some variables, but this is not what we are going to talk now. The exact thing that we need to do to see, which is the first one, which is the slice number. So the slice number is a parameter that will be returned automatically when the user, for example, when we choose the image. So when there is an image, so this slice number will be the value of the slider. So whenever we change the slider, the slice number will be changed. This is what is the slice number. But by default, it is 0, because when we first initialize the visualizer, so at the beginning, this slider is at 0, and we did not change it. Then we need to take it to value 0, and then we need to show the first image in the directory. So this is why we are putting it by default equal to 0, so that we see the first image. Okay. So here slice path. So we are returning the first path, because here DICOM files is a list containing all the DICOM paths. So we are just returning the first part of the list, which is this one, because here we have the value of the slider. It is a float at the beginning, so we are converting. It is a string in reality, but it is like something point something. So for example, 2.1. So we cannot convert it directly into integer. We need to convert it from string into float, and then from float to int. So that's why we are using like this. So this value at the beginning, it is a number, but the type is a string. So we are converting it into float, and then we convert it into int, so that we take only the part which is 1, 2, 3, 4, something like that. Because we cannot return a value from a list, like we cannot put list and then 1.5. There is no index 1.5, so it should be integer. And then here we are returning the maximum and minimum values of each slice. Because you remember when we choose, let me open a directory, visualize. So whenever I am in such a slice, for example, this one, by default, it takes the minimum value and the maximum value, and it will load them here. So this is by default. So to return these default or this by default values, we need to go here and use this function that I created. So this function, which is here, it takes one DICOM file and the path to one DICOM file. So it reads it and returns the min and the max of this DICOM file. And then after having them, we are like showing them in the, because you see slider max and slider min. So we are initializing them in the values. And of course we initialize them in the, how do we call it? The labels. So you see whenever we have the slider, we have this label, which is the title, we have the value, and we have this label that prints the value. So we need to update this as well. Okay. So after doing that, we are just okay. We are enabling the sliders. So as I shown you, when we just open the application, these sliders are disabled. So whenever we click on visualize and the image is here, these sliders will be enabled, so we can change them. So for this reason, we are enabling them here, and we are enabling the apply button. And of course, we need to disable the change button. Whenever the apply button is enabled, then the change button should be disabled. So something like this. We cannot have them both enabled at the same time. Okay. So then next, what we can have, which is the slide configuration. Okay, these are the values that we are giving to the sliders by default. And then, okay, this is the most important thing part. Here, what we are doing, we are having the slice after normalization. If you remember in our latest code, when we were doing the conversion from DICOM to PNG, or when we were doing the visualization of a DICOM file, we had a function called normalize visualize DICOM, which we had two versions, version 1 and version 2. So here we are taking only the version 2. I will show you what does it mean, the prepare DICOM. So you see prepare DICOM, it contains the same thing that we had in the visualize and normalize functions. But I am taking the second one, as you see, and it is the same thing. I just copy it and paste it here. So we are doing the same thing, reading DICOM if we want to show, and then we have the max value, min value, and we had the Hounsfield max, Hounsfield min, and everything is the same. And we are applying these ranges, and everything is the same that we had before. So you see, this is the function that we had and just using it inside our application. So we are returning the normalized slice, and then we are using the function show. So this function show that I created here, you find it just here. What does it do? It takes an image. It do some, because we cannot just take an image which is a NumPy array or something like that and visualize it in a Tkinter application. We need to do some pre-processing on that image, so we convert it into an image ITK type of, which is from Pillow, and then we use it and create an image inside the Canva viewer. So you remember here by default it was an image by default, so it was a Canva, actually Canva having that image by default. But now whenever we choose a slice, or whenever we do something like this, we are sliding the images or scrolling on the slices, what happens? We are recreating a new image for this Canva. So this is what happens when we call the show function. What does it do? It just creates a new image, which is the new slice or the next slice or something like that, depending to the slice that we take. And here is what it is coming. So we just call this function in every time we give it the new image, and it do the same thing here. This is a NumPy array, and it do all these parts and show you the image in the Canva here. And yeah, visualized. Okay, yeah. And whenever we are doing this, we are updating the max and the min values of because here we have the max and min v, which are a global. These are global variables that has been used for all the functions. So whenever we change these, we should always have an updated value of the max v and min v. For this reason, they are global functions, so that they are recognized on all the functions and will be updated whenever we do a change in any function in our code. So if, for example, we don't put them global and we change them in this function, and then we want to use the value in another function, then the second function will not recognize the latest value of these min and max v. So we need to put them global so that we use the same value. So whenever I change here, for example, and do like save PNG or something, it need to take the new value that I took and not the old one. For this because this save PNG, it is a different function than visualize. So we need to update the values for all the buttons or all the functions. For this reason, these values should be global, as you can see here, and here, and the same thing for the other functions. Okay. And yeah, and after that, we are just updating the configuration for the notification. We are just changing the configuration of the notification label, which is this part here. So whenever the image is here, then we can just click on, you can now adjust the contrast so that we know that everything is set, and you can change the contrast here. Okay. So this was about the visualization part. In the next videos, we can talk about other parts of this application. Now let's talk a little bit about the show information button, which is this one. So whenever I click on show info, it's like just there is a window that pop up here, and we see all these information that are available directly in the DICOM file. So how we are getting this thing just set up here? In reality, it is just creating a new top level, which is top level means that you are creating a new sub window or sub application from your main one. So this application will be always the main, and top level will be like a child window or child application, which depends always to this one. So when if I open, for example, show window here, if I close this application, this one will be closed as well. It depends always to this main application. Okay. So I am just calculating it and creating a label and showing it there. This is all what is happening. So, but when we how I am returning the information of the patient, I have here another script that is attached with the same script for the app that we are using for this for all the application. But I wanted to put this aside so that I don't have everything on one script, especially this function. You see that it contains like about 50 lines of code, but it is only about printing the information. So I didn't want to put it there. So what is happening? This function return information takes the path to DICOM and it returns image type, everything here about the DICOM file. If you remember, all these tags we talk about them when we were talking about showing information or showing the tags or even changing the tags of a DICOM file. So this is the same thing, but instead of changing them, we are just showing them. So I just take them and create a string, which, for example, study ID, and then here there is study ID, and I jump the line and do the same thing for the others. This is what is happening, and you see that the same thing that we did is happening here. So whenever I call this function, I give it a path to one DICOM file, because I don't need to give it all the DICOM files because they all have the same information. So I give it one DICOM file and it returns everything. And that's everything that will be returned, which is info. So I wanted to divide it into info1 and info2, because if I take everything in one line, I cannot show them in the application. So just for the customization of the application, so that it can be visible, I am dividing all the information into two parts, and then I can put them into two columns, the same thing that we had here. Because if I put this with this, I cannot visualize it directly in the application. So I am splitting them here so that you can see them. Okay. Right. So yeah, this is show information. I am just returning them in this info1, info2, and creating one label, and I think two labels, one for the first column and second label for the second column. So, and for the first label, we are printing the info1, and the second label, we are printing info2. So this is how it is happening, and there is this part only about the title. So here we have file information, which is here, this one, file information. So this is what I did. This is only a small function and easy to use. And if you want to customize it, of course you can customize it. You see everything here is customizable. You can change the font size. If you want to delete some of the information, then you can come to this function and delete some of them, and will not be called and or printed as well. And yeah, this is how to show the information. Now let's go to the anonymization part. So if I go to anonymize, you see that I have a function directly called anonymize. So what does this function do? So I have of course, at the beginning, we need to check if the file path is there. DICOM files are in the path directory that we choose. So if they are there, then we can proceed to the other parts. So what is happening? I will go here. There is this function that will do the anonymization. And if you remember this anonymized case, I don't know if I used the same name, but you see anonymized, but it contains everything, the same that we saw in our course. So we are just taking the patient name, giving it an empty string, the same thing for the patient's birth date and study ID and patient sex. So as you see, I am just taking some of the information, but if you want to add more, then you can just jump the line here and take some of these and put them as empty string. Or if you want to put the word anonymize, then you can just write it here. For example, anonymize or something. So you can put anything you want here, and everything will be used directly in this function. So whenever we call the function anonymize case from app functions, then it will be used in this anonymize. And yeah, we are doing a for loop so that we can anonymize all the files or all the DICOM files that are in the directory. So if we have only one DICOM, it will be anonymized. If we have like 10, 20,000 DICOM files, everything will be anonymized. But the only thing that we are going to need is to choose the directory where you want to save your DICOM. So here we have path to anonymize. So it is a file dialog where it will ask you, if you remember in the first video when we saw the application. So if you click on anonymize here, for example, anonymize, so it will ask you to give the directory where you want to save your anonymized DICOMs. And then everything will be opened here. And yeah, everything will be converted and saved there. And after the operation, there is a message info here that will be shown saying that the anonymization is completed or completed. Okay, so this was how to show the information and how to do the anonymization. In next videos, we'll see how to do the conversions and the other things. See you. So for the changing the contrast part here, as you can see, we have these two sliders, the min and the max, that contains the house field min and house field max. So I will show you how it works in the code. So if you want to change it or customize it for your own project, then you will see where this part is in the code. So here we have two functions, change max and change min. So the change max function will change the maximum value of the house field max, and the change min function will change the value of the house field min value. Okay, so it will do the same thing that we were doing before. As you can see here, the first thing is just we are reconfiguring the value. So here I need just to change the value in the label here. So whenever I change the value, it should be changed in the label. For this reason, I am adding the configure and then text and changing the value here. Text and changing the value. Okay. And then the important part here is to call the function prepare DICOM, which is the same function that we used before, which has the same role of the normalize visualize function. So it just takes the DICOM slice, the min value and the max value, and it returns the unsigned integer 8 bytes image. Okay. So whenever we press on the change min or we press on change max, we are calculating the function and giving the new vmin and vmax. The new vmin and vmax are returned from here. So whenever we change this, we have a new vmin. Whenever we change this, we have new vmin and vmax. Sorry. So if we call this function, we change it, or the same function for this for the minimum, we are using the same function here. And then we press on show. So show, as you remember, it takes directly the image, the unsigned integer 8 bytes image, and prepare it for the ITK image visualizer, and then it creates a new image in the viewer canvas and it shows it directly. So this is what is happening. We have change max, change min. Whenever we call one of them, we take the value of the slider, take both values of the sliders, and we call the function prepare DICOMs. We prepare the DICOM and we show it in the canvas. So this is how it is happening. If you need to change anything in this function, you can just customize this here. Otherwise, you can use it directly as it is. If you have any questions about this, of course, you can just leave them in the comments or in the community discussions. See you in next video. And for saving the PNG and MP4 video, so if I want to convert all the slices into MP4 video, or if I want to convert all the DICOM slices into JPEG or PNG images. Why I am saying JPEG or PNG? Because you see here I am using only PNG, but for you, if you want to use them JPEG, then you need just to go to the code that I will show you and change PNG by JPEG, and you can directly convert them into JPEG. Okay, so for the save PNG, that can be save JPEG function. Here we are doing the same thing that we were doing in our course when we were converting a group of DICOMs into a group of PNGs, if you remember. So this is the same thing, like we are just reading. At the beginning, of course, we need to check if the DICOM file list contain DICOM paths. So if the directory really contain DICOM files or not. So this is the first thing that we need to do. And then we just create here a path where we need to save the new PNG file. So this is a file dialog when it shows the window. So whenever I click on save PNG, you need to choose the directory where you want to save your PNG images. So after checking this, we need also to check if we chosen a path to save the PNGs, because if we don't do that and then we do the conversion, there is no directory to save your file. So you need to check if the directory is set correctly, and then we go to the for loop that will take each DICOM file from the list and does return the image name and do the preparation and convert it into image, and then save it with the same thing that we did. Save the path to save the PNG plus the name of the file plus the extension PNG. So if you want to save it as JPEG, then you need to change this into JPEG, as we can do and as we did before during the course. Okay. So this is for converting the PNG, the DICOM into PNG. Now let's go to the MP4 part. So the same thing for the MP4, the same function that we used, or the same lines of code that we used while we were doing we're talking in the course. So we explained everything in the image and in the function, and we wrote everything that it is here. And you see that this is the same thing. We are checking if the DICOM directory is not empty, and then we are initializing the folder where we want to save the file, which is the MP4 file, and then we are checking if we have initialized the path where to save the MP4 file. And then what we are doing, we are just because as you remember, we need to have the frame size, which is the width and the height of the frame. So I am returning it from this part. So I am just taking one example, which is one DICOM image from the directory, and just calculating the width and the height using the function shape. And this frame size, I am just returning it. I'm putting it here. And of course, for the frame per second rate, I am putting it 15 as well. So if you want to change it, you can just come here and change this value into something that you prefer. Okay. And then after doing that, as you see, we are just initializing the output variable, which is the video writer. So we go to the for loop where we just read the DICOM file and do the preparation. And then after that, we convert it into CV2 image, and then we write it in the output variable. And after that, we do the release. And after completing all the conversion, we show, like with the text notification or text box, we just show the message saying that the MP4 file has been created. This is how it is happening. So you can change all these messages, of course. So just come here and you can add whatever you want. And the same thing for all the other functions. So this is how to save the PNG and MP4 files. Now in the next video, I will just show you how you can use the code. So now I am showing you how, if you want to change it. So each section of the code, I put a video about it. So whenever you want to change one part, so for example, this part or this part or this one, or how the backend is working. So if you want to change the function that is doing the visualization or something like that, I just put everything in one video. So you can just go to the point if you want to change only one thing, not all the application. So you can check that. And of course, if you have questions about this, you can leave it in the comments or in the discussions in the community. And yeah, in the next video, I will show you how you can directly take the code if you want to use it as it is without any changes. If you want to take it directly, I will show you how you can clone the repository from GitHub and use it directly. See you in next video.